And welcome to JDConf EMEA. EMEA stands for, it's not just my name, EMEA stands for European, Middle East, and Africa. I'm your host, Rory Preddy, and I'm going to spend just 2 minutes going through the agenda, and then we're going to see our first guest. This is day 2 of the session, and we had some incredible speakers. But don't worry, we've got even better speakers coming up. So first of all, let me first tell you a little bit about me. So I work in developer relations. It basically means I throw parties for developers. And you can follow me on @RoryPreddy on the tweeters. Now, Learn TV, code of conduct, be good to everyone else. Post comments that are nice on YouTube or Learn TV. Yeah, so be sensitive to everyone else. If you feel that you have any issues, please reach out to us and we'll handle it. So we've got a stellar lineup of individuals and teams here. So much so, like, I feel incredibly threatened by the people that are speaking here. I had to go watch them and try and, like, you know, rekindle my ego with that. So first of all, we've got Mark Little is going to do a keynote with me on JDConf, just go through the partnership with Red Hat and Microsoft. Then we've got Ephemeral Vm with Alina. We've got debugging at scale and production with Kubernetes on your containers. You really want to stick around with that, because we've got 2 sessions on Kubernetes. And then we've got Bayesian Optimization and Java performance in Kubernetes. Yeah, I had to Google that. Okay, all honesty there, I had to Google it. I had to understand exactly what is going on there. But I'm confident that I can run Kubernetes now, as long as I actually optimize it successfully. We've got XSS injection and a hacker's guide to it. And then coding Spring applications with Visual Studio Code. And then finally, we round off with code spaces and test containers. So it's a really stellar lineup here. Now we've got Java developers. You want to go there, you want to go to JDConf Learn on demand. You can go to JDConf on demand. And then more resources. Look at this. Mark Little is drinking a sugar-free Red Bull like me. I knew we had more in common, Mark. And my next guest really is Mark Little. And we've been chatting for the last week around this. And I think Mark trusts me enough to actually let me babysit his children by now. So I'm going to say goodbye. And so reach out and do the chat. And we're here to have fun, to do everything and to be informative. And I want to bring out Mark here, and then enough about those PowerPoints, and tell me a little bit about yourself, Mark.
Good to be here. I'm not quite sure if I still trust you enough yet for my kids. So I'm Mark, VP of Engineering at Red Hat. I run the middleware engineering groups. I came to Red Hat in 2006 from Jboss, when Red Hat acquired Jboss, and in the intervening 16 years, we've grown that to include more than just the app server. We have integration with Fuse, we have API management, we've got business process management, lots of different middleware capabilities, which we're now growing, or have been for the last few years, growing to to run on OpenShift and in the cloud with hyperscalers like Microsoft. So, like I said, thank you for inviting me.
So I must tell you that I'm actually a huge fan of Red Hat. It's one of the reasons why I actually got into Microsoft. So long time ago, we looked at Visual Studio Code, and we started moving Visual Studio Code into an off-process language server. And I remember I spoke to the head of DevRel, Patrick Chanizan, and I said, listen, I'm in love with that language server. And I see the world moving to a more distributed IDE and developer experience. And here I am speaking to Mark Little, VP of Red Hat Dev Tooling, and like, I have to pinch myself, which is really difficult, because I was walking in the morning in the freezing cold Johannesburg air, which is like 20 degrees. So I'm very cold and I'm very exercised yet. So I've got some questions I want to ask you, and then you can ask me some questions also, because I'm just above, on cloud nine, right? So first, thank you about and introducing yourself and everything. So you mentioned a few products there, and I know that I've done a few sessions around those products, and there's so many offerings that Red Hat has with partnering with their Zero. It can kind of get a little bit overwhelming that you have so many products, though. So touch on some of those products that you have for Red Hat products on App Service, and tell me what we can look forward to in some of those products.
So I think, my personal favorite has got to be EAP, our Enterprise Application Server, which is Jakarta compatible. So I think we did, as in Red Hat and Microsoft, we did an announcement about that a few months back. Obviously, EAP's got a huge heritage in the Java EE app server domain, going back to Jboss AS, when Mark Fleury created Jboss before, like I said, before Red Hat. It's probably the most popular open source application server in the world, and it's good to have it on Azure. Other things that were, you mentioned VS Code. I know that's not necessarily exactly in that space that you're talking about, but I did want to say, following on from what you were mentioning there, I'm incredibly impressed with the work that we've done together on the whole VS Code thing. I think you were telling me, I have some figures, but I think you were telling me the other day, I know it's millions of downloads.
Millions of downloads, like 12 to 15 million downloads. But we have active users right now using that language server, 1.5 million developers.
Yeah.
Now, understand there's like 10 million Java developers in the world, as per all the stats that go in there. That means, nearly 15% of them are actively using Visual Studio Code and Java.
Yeah.
When I speak to developers and I say to them, why use this tool set compared to others? And they said, first of all, it's a delightful experience from start to finish. I did a session, I've recorded a session for Microsoft Build coming up, and I go from the browser, and I just go in the browser all the way through to the Azure service, though, and I end the session with, wow, that was, even for me, that was just delightful. Now, paired with GitHub and a lot of those features, though, what you get is productivity and developer velocity. And I really think that with the Red Hat language server and the Red Hat toolings with Jboss EAP, you get increased velocity. Now, gone are the days that I came from a banking background where you had a deployment, and I remember saying to one of the engineering team leads, okay, I've got this WAR, I need to deploy it. When can I go live with it? And at the time, it was like June. He goes, summer. And I go, but it's June. That's winter in Johannesburg. He goes, yeah, you can go there. And now we're going multiple times live per day, and we're having GitHub Actions and CodeQL and all these open source tooling, though. And it's just, I'm baffled by the developer velocity. So yes, I agree with you totally around the VS Code and the incredible experience that the developer has to look forward to today. We've just launched also Jboss Clustering on EAP. And one of the things that I actually used to, when an interview, when I used to apply for a job, and people used to say, so Rory, exactly why should we hire you? I go, I know Jboss Clustering. And I go, you're hired immediately right there, because it was such a kind of like an incredible skill to have. Touch on Jboss Clustering with Wildfly and what that means to users.
So, I mean, you're right. Back in the day when application servers in general started to add clustering, it was tricky, to say the least. You didn't have auto clustering, which is essentially what we've now got. We've had this in Wildfly and EAP for a number of years, where you literally spin up another EAP instance, and they essentially auto detect. You don't have to really change anything from your application point of view. And you can have any number of EAP instances in a cluster. And once you've got clustering, you've got potential for high availability and load balancing, and it's all pretty seamless. Like I said, we've had that in EAP for a long time. Predates cloud, let alone predates Kubernetes. When cloud and kube came along, we had to make some changes to the way in which clustering works, because Kubernetes does clustering itself, for instance. So you don't want one clustering mechanism to compete with another, particularly if Kubernetes is essentially the dominant instance. So we've made some changes to EAP. So once you deploy into a cloud, kube-based or not kube-based, it works with the clustering mechanism that's basically there. And again, it's pretty seamless. You don't need to go in and hack XML configuration files, or even lower level than XML.
So the other thing also is caching. So we have not only Red Hat caches, but we also have third-party caches. And it's also something that I remember basing my career on: first-level cache, second-level cache. I remember phoning someone in Argentina about Jboss rules and working out how the caching system works, though. So this was even before you did the renaming to rules. To the rules engine, though, and then working out, that's how long ago it is, though. And the caching services that you have really are incredible with the Wildfly and also that. And I just want to do a shout out for if there is a Redis teams out there listening to this live call, though, because when you have Jboss, you have Redis, and then you have the clustering around that. It's a really great experience, though. But we also support Microprofile and some of the Java EE specs, though. So let's touch on a little bit about, what do developers, now you've got Jboss, you've got the platform, what can they look forward to Jakarta EE and Microprofile?
All right, so let's tackle Jakarta EE first. So for those of you who don't know, Jakarta EE is essentially the open source version of Java EE. Java EE or J2EE, if you haven't looked at that for a long time, was an enterprise Java standard that was developed under the original leadership of Sun Microsystems, and then Oracle, when Oracle acquired Sun, and with cross-vendor support. So Red Hat, IBM, HP back in the day, lots of vendors were contributing to this series of specs. In 2018, Oracle approached Red Hat and IBM and Tommy Tribe, who are another Java EE vendor, to move that to an open forum or a foundation, and we selected with them the Eclipse Foundation. So I know we were talking about VS Code before. A lot of people might think of the Eclipse Foundation as the place that you get the Eclipse IDE, and it absolutely is. That was essentially what created it. But these days, the Eclipse Foundation does a lot more than an IDE. And one of those things that it does is now Jakarta EE. So all of the specs that were in some ways proprietary, not necessarily everything was open source, they got moved to the Eclipse Foundation, got renamed to Jakarta EE. And now that is evolving again based on lots more, in fact, vendor collaboration. So Microsoft, Alibaba, lots more people and lots more vendors are involved in Jakarta EE and the Eclipse Foundation than were ever involved in the Oracle/Sun Java community process version. So collaboratively, we're looking to move that towards being more cloud native, also more streamlined. So for better or for worse, Java EE got this perception that it was very monolithic, very slow moving, and you needed to have all or nothing. And to be fair, some of that perception was reality. I remember one of the first things that people used to do with Jboss back in the day was try and trim it down. And this is way before the Jboss company was acquired by Red Hat, and they've been doing that with lots of other app servers. So there is some reality to that perception. So we're working really hard on that to try and make it more cloud native, if you like. The other thing that you mentioned, though, is Microprofile. So Microprofile actually predates.
You need to tell us a little bit about Microprofile and also Graal and also all of the other niceties that sit on front of it, because everyone has jumped on this bandwagon now. And right now, there is literally, every time I start up YouTube, there's something new about that. So yeah, demystify it for them.
All right, so Microprofile started in 2016 with the London Java user group, Red Hat, IBM, Pyara, and Tommy Tribe. Essentially, we were working with Java EE at the time. This is, like I said, this predates Jakarta, so it predates the move to the Eclipse Foundation. And at that stage, Oracle wasn't really evolving Java EE quickly enough. We were seeing lots of things happening with microservices. Each of the vendors that was involved and the London Java user group were seeing people taking those app servers, Jboss, for instance, or Pyara, and trying to pare them down to be more applicable to a microservice environment. So we decided to take some of the specs from Java EE, create Microprofile, and then try and rapidly evolve new specifications in a fully open source manner that would be much more applicable to microservices, and essentially say we don't want a lot of the things that you might get from your typical application server. That was Microprofile. We moved that to the Eclipse Foundation at the tail end of 2016. Microprofile has continued to work very rapidly. I think we're on version 5 now, and there have been lots of sub-releases of that, lots of new specs. So I think we went from 3 specs initially in 2016 to something like 14, 15 specs that have been ratified now, and more that are being worked on by the community. And Microsoft is involved in that community as well. So it's great to see, again, much wider collaboration. One of the things that we need to figure out is how does Microprofile and Jakarta EE work well together? We don't know that yet. There is no answer. Those communities are continuing to have those conversations and try and collaborate. But you'll see a lot of app server vendors are now adding Microprofile into their app server. So EAP has that. So I mentioned, EAP is now on Azure. You can have an EAP application that only codes to the Jakarta EE specs. Fine. If you want to code to the Microprofile specs, which is a subset, or actually it's more of an overlapping subset, you can do that, and that's through something called EAP XP. So the XP component is the Microprofile specs, and you can have a fully compliant Microprofile application that sits on EAP and doesn't have to use any of the Jakarta EE capabilities, which means that if you then want to move it to another Microprofile compatible implementation, you can do that, and you don't need to worry if that one says, I don't even use anything from Jakarta EE. You should just be able to do a lift and shift. It's interesting that you did mention Graal VM. That's actually not in Microprofile. It's not in Jakarta EE, but I think it's a huge innovation in the Java space in the last few years. For those who haven't heard about it, essentially Graal VM is a big project, but the thing that I think is probably the most interesting bit is the Java native image aspect to this, which essentially allows you to take your Java bytecode, which we all know for the last 20 years allows you to build once and run anywhere, but you can then compile it. So you get rid of that build once, run anywhere capability, but you then end up with something that is much smaller typically and can spin up much quicker. So there are trade-offs. But what this does, and Red Hat has shown this, other vendors are using it and have shown this too, it takes Java into the realm of being absolutely applicable for things like serverless, where you do want to spin things up very, very quickly, and maybe they only run for a few seconds before you get rid of them. Trying to do that with your traditional JVM, it's possible. You have to do various tricks, but it's still not necessarily as efficient. And it also makes Java, in the native format at least, comparable with the likes of Go and JavaScript in terms of its density. So you can get many more instances of a native imaged Java application crammed onto your public cloud node than you could with a traditional JVM. Like I said, not specific to Microprofile or Jakarta. They can be used, Graal can be used in lots of different areas, but we are seeing participants in both of those upstream communities looking to use Graal VM.
It's an incredibly exciting time to be a Java developer, and I always marvel at now the JavaScript developers are compiling their code, but we're double compiling our code into native imaging there. But you also have other tooling, like you told me yesterday when we were preparing for this. You have a new testing framework that you told me about, that I went and downloaded and played with it, that I was really excited about. Though, tell me a little bit about that testing framework and some of also the other tools that are coming up.
You'll have to remind me about the testing framework, unfortunately. It's been a long day already.
I misspelt it. It's Aquavit. Aquavit.
Oh, right. Oh, yes. So yeah, because we do have a few testing frameworks. So this one is great. And interestingly, again, it's another Eclipse Foundation project. So, or at least it is these days. Hopefully some people in the audience, or lots of people in the audience, will know about something called Adopt Open Jdk. So this is an effort that was created, I think, about 5 years ago. IBM and the London Java User Group initially kicked it off, and then other vendors like Red Hat and Microsoft started to get involved. And essentially what Adopt Open Jdk was doing was trying to be that single point of contact for developers anywhere in the world who wanted to get a solid build of Open Jdk for their platform. So, if you were running on Ubuntu and you wanted to know what is the best Open Jdk implementation that I can get for Ubuntu, you could go to Adopt Open Jdk and you could download an official version from that. Now, Adopt Open Jdk didn't have the rights to what's called the TCK, so that's the certification toolkit, essentially, or test suite that Sun and Oracle have, which TCK compliant or compatible implementations pass, and it tests some fairly low-level capabilities of Java, not specifically Open Jdk, but any Java implementation that wants to claim to be Java needs to pass the TCK. So like I said, Adopt didn't have that. So over the last 5 years, I think they had, the last figures I saw a few weeks back, something like 350 million downloads in 5 years from Adopt. Those, to ensure that those downloads were solid and people could rely on them, even in mission critical environments, that group built something called Aquavit, which is a test suite, tens of thousands of tests that they run that obviously test a lot of capabilities of Open Jdk in lots of different environments, including the graphical side of things, headless, server side, client side. All these things are tested by Aquavit, and it's a very, very rich test suite, and it's continuing to evolve. When Adopt Open Jdk moved to the Eclipse Foundation, all of that moved to the Eclipse Foundation, and that became known as Eclipse Adoptium. That happened about a year ago, and I think in the last 12 months, again, the latest figures I saw was something like 40 to 50 million downloads of official Open Jdk builds from Adoptium. So I think it's a phenomenal community effort there.
I hear the millions and everything like that, and the numbers just baffle me. And now, like we just launched Playwright, which is the Microsoft testing suite, and allows you to do Selenium front-end testing around that. I really need to do a head-on-head with that and see how we can leverage and do a great partnership between that tool suite, testing suite, and then Playwright. And we've always been great partners. Like one of the things that that you touched on is the partnership between Microsoft and Red Hat, and the stewardess of Open Jdk. And Microsoft really is doing a lot to engage with the developer community. We have the Microsoft version of Open Jdk. We have the Visual Studio. We have GitHub Actions. And we have CodeQL, which also looks at the vulnerabilities that you can get in your code for free, actually. I don't know if you're aware of that. You've got a public repo. You can find out your vulnerabilities for that. Where do you see the partnership moving towards, and where also would you like me as an advocate to focus on our developers and say, listen, guys, this is where development is going to go. Where would you like me to lead them into the path of righteousness?
So first of all, it would be great if you have this test suite and you can convince the powers that be at Microsoft to donate it to the Aquavit effort, because I think if we can make Adoptium again, like Adopt Open JDK, the single source of truth for people to get really good, the best, the most solid and supported versions of Open JDK. That would be phenomenal. So that would be a great thing for us to build on the partnership for. In terms of the next bit of your question, I think it's almost like what I was saying a minute ago about Adoptium. I think we've got to get away from the era of having each vendor that's really interested in Java trying to be the single source of truth for Java, because that doesn't scale and it's confusing. Red Hat can do quite a bit, Microsoft can do quite a bit, but there's going to be a lot of overlap. And I think if you look at what other languages are trying to do and biting away at Java's lunch, if you like, I think by collaborating more, those vendors can really make Java continue to be extremely relevant. So it doesn't have to be in the Eclipse Foundation, but I'll use that just because we're collaborating there anyway. But having something where we can all come together in a vendor-neutral manner and actually grow the information that we put there. And yes, maybe there are some things that we have to have on a bespoke, vendor-specific site, Microsoft's or Red Hat's or IBM's or whatever. But if the main body of knowledge and the main community efforts are in a vendor-neutral, collaborative manner, following good open source practices, I think that would be phenomenal for the vendors, but also for those 10 million Java developers that we talked about.
That was a really good question. Basically, make sure that we all get along. Make sure that Java is at what I would say is a honeymoon stage. Developers are falling in love with it. Developers are falling in love with the Red Hat tooling, and make sure that they understand there is no more them and us. It's everyone together. Yeah. Mark, thank you so much for today. I'm going to bring in the next speakers, and I want I want them to meet you also. And then let's do a changeover. And I love how we do this in a changeover, just a seamless changeover. But before we go, is there a call to action that you want to give all of the listeners out there, a URL or a call to action?
I would say, go to the Eclipse Foundation, look at Adoptium, look at Microprofile, look at Jakarta, and take a look at Graal VM and Quarkus from Red Hat, Quarkus.io.
Oh, no, you didn't. Hey, you can't just drop Quarkus at the end of a talk, though. And, oh, my gosh. Okay, now I'm going to be called in by HR.
Quarkus uses Graal.
No, okay, it's fine. Everyone calm down. I know you mentioned Quarkus, and there's waves now. The whole ecosystem now has just kind of burst from the seams, though. Okay, so next in the speaker lineup, and I've got my little sheet here. We have Alina, and Alina also is one of the people that I find incredibly threatening with the incredible talk that you did there. And you've just branched off with Graal and Quarkus, and Alina really is well, she is Graal. She is Mrs. Graal. So yeah, so Alina, Mark just gave you a great introduction around Graal, and you've got an incredible talk that I'm going to drop off. Mark and I are going to drop off, and you're going to start with that incredible talk around how to actually use Graal, the new improvements that you've done, the new native images that you've done there. You've just launched 22.1, and over to you, Alina.
Hi, good morning, and thank you, Mark, for doing a great intro to my session. I tweeted already, so thank you for that. And yeah, I think we're good to go, right? You can see me, you can hear me, I can start sharing, right? Okay, I think we are good. So hi again, everyone, and good morning from sunny Stockholm. My name is Alina Renko, and I'm a developer advocate for Graal VM at Oracle Labs. And let me just get my slides so we can get going. Okay, this should be good. We can in 30 minutes, and that's going to be a challenge, but let's hope that I can give at least you and solve it over you. So first thing about Graal VM, what it is and what it does, it's a high-performance virtual machine, and it can run all those languages that we see on top here and also work in a number of environments that we see below. So it can obviously run Java and JVM languages, such as, for example, Scala, but not just that. So we also have implementations for languages like JavaScript, Ruby, R, and Python, and all of them can run on Graal VM with high performance. And the best part is that they can also interoperate between each other, still with high performance on Graal VM because it supports all of them. And what's also interesting about Graal VM is that it's highly embeddable. So you might have heard about the context of Open Jdk, in which we can run your normal unmodified Java applications in JIT mode. But what's interesting is that Graal VM can also work in context of environments such as Node.js, where we run unmodified Node.js application, or even be embedded in a database to execute those languages that we see on top here right in database. And last but not least, Graal VM also has this standalone mode, so native image mode, where Graal VM is the only runtime that we would need to execute your applications. But we will get to that in a second. So what Graal VM offers for us, and more specifically, what does Graal VM offer for Java developers? So there are a few things. First thing is that you can get more performance with Graal VM in a JIT mode. So that is your normal way of executing applications on a JDK, where you have basically a normal JDK just with a different, highly optimizing Graal compiler. That is one thing we will talk about in detail in a second. Now, another thing, and a very interesting and exciting one, and that is something that Mark mentioned in his keynote, so thanks to him for that, is the native image mode. So that is this ahead-of-time compilation mode, where you can take your application, compile it ahead of time into a native executable, and get those amazing benefits of fast startup time and low memory consumption. And last but not least, it's also a Polyglot VM, so all those languages you've seen on the previous slides can easily interact with each other on Graal VM as a platform. And to give you an idea of how it all works and how it looks under the hood, so this is a high-level overview of the Graal VM architecture. So what's interesting, what you see here below is as the base runtime that we use for executing applications, we have just the normal Java hotspot VM that we all know and love. So under the hood, there is a Java hotspot VM. But what is different about it is that we plugged in this brand new, highly optimizing Growl VM compiler that has quite a few new additional performance optimizations. And this is where you can get this additional performance benefits from when you are running on Growl VM as a JDK. So this kind of base layer is how we execute Java and JVM languages in JIT mode. But you see that there is another layer on top as well. That is our language implementation framework. And that is the way how we execute and implement previously all those languages such as JavaScript, Python, Ruby, and so on. So this is basically how Growl VM looks from the inside. And if you would like to get even better idea of how it works and what it looks like from the inside, Growl VM is also a big open source project. So our main repo is on GitHub, and if you're curious about it, I encourage you to go and take a look. In fact, if you're a Java developer, it should be quite interesting and fairly accessible to you because our development is happening in Java. So if you're a Java developer, you can easily understand what is going on there, relate to it, maybe learn some good practices for it. It's a great project and interesting to follow. So go to GitHub and give it a like, follow it. It's really interesting to follow. Now, let's talk a bit more detail about how Growl VM can execute Java. So there is this important distinction that I want to make, that there are a few ways how you can run Java on Growl VM. So you can run Java on Growl VM in JIT mode as on a JDK, as you, for example, maybe run your applications on Open Jdk or any other JDK, and that is still possible on Growl VM. So you can just run your applications with the Java command, how we see on the left here, and that works on Growl VM just as on any other JDK because we do have a full-blown JDK inside Growl VM. So that is one thing. And the reason why I stop here and I emphasize this is because the second mode, right, the native image mode, is so exciting that sometimes people associate Growl VM with it entirely. So basically, when they say Growl VM, they mean native image. And it is fascinating and very helpful, right? The native image component of Growl VM. But that's not the only thing and not the only way to run Java on Growl VM. So I just want to make this important distinction, right? To say that with Growl VM, you get options, right? So you get to choose how you want to run your applications on Growl VM, and based on what you're trying to accomplish. So, for example, what your performance goals are, you can choose either the JIT mode or the native image mode if you want to optimize for the best possible startup performance and resources usage. So yeah, a couple of ways to run Java on Growl VM are as we see here. And if I'm being entirely honest, like I don't want to confuse you, but in fact, as of some time ago, there is even one more way to run Java on Growl VM. So I will not stop here because this is not the topic of today's talk, but just to give you a full idea. So on previous slides, we've seen that there are all those languages implemented on Growl VM's language implementation framework, which is called Truffle. So languages like JavaScript or Python. And in fact, we also have a similar implementation of a JVM on Growl VM. So in fact, it could be running Java in a third way on Growl VM, and that is through this Java on Truffle project, which will give you another execution profile and even better interop with all those other Truffle languages. So this is not the focus of today's talk, but just to be fair, I wanted to mention that there are in fact 3 ways of how you can run Java on Growl VM. But let's take a closer look at the first 2. So why would you use them, how exactly, and when should you choose each? So Growl VM as a JDK, this first JIT execution mode. So in this mode, as I said, basically as the runtime, we have Java Hotspot VM. So you get all your favorite tools, all your favorite capabilities. The only thing that has changed, as we see on the chart below here, is through something called JVM CI, so JVM compiler interface. We plugged in this external compiler, the Growl compiler, and the rest basically stays the same. So you have a new highly optimizing compiler. The rest is your just normal JDK as you know it. So you can imagine migration is quite easy, right? Because it's your normal JDK, your normal way to run applications. So migration is as easy as just swapping your JDK distribution for Growl VM. And if you're curious, we have builds available for Java versions 11 and 17. So yeah, if you're on either of those very easy for you to migrate to Growl VM, go ahead, give it a try, and tell us how it works. So yeah, migration is very easy. You get to use all your favorite tools, and what you get after switching to Growl VM is higher performance in many, many scenarios for many workloads. And to illustrate the thought about higher performance, so I want to share some benchmark results with you. What we are looking at here is Renaissance benchmark suite, and that is comparing Growl VM's performance to the baseline, which is Open Jdk. And yeah, so Open Jdk are those yellow bars. Red, that is Growl VM Community Edition, which is our open source project. And the blue one, that is Growl VM Enterprise, which is a commercial version of Growl VM. So comparing to Open Jdk, you can see that, well, obviously each workload is different and performance numbers will be different, but you can see how for quite a few workloads, you can get additional performance benefits with Growl VM. And if you're wondering what kind of performance benefits you can expect for your application with Growl VM, probably there is no universal answer because every application is different. It's written differently. It uses different dependencies. So the best way to figure it out would be to actually take some sample of your workload, run it on Growl VM, see how it works for you, see how much performance you get. So the easiest way to figure out expected performance is actually to try it on your own application. And yes, I encourage you to do so. Now, let's talk about native image, right? So it's quite exciting, and I want to dedicate quite a bit of time to it because I think you will like it a lot. So native image is this ahead-of-time compilation technology that allows you to take your Java application, compile it ahead of time, and produce this platform-specific native executable of your application. And the reason to do so would be that this application will start very fast and will use very little resources because it is optimized and compiled ahead of time, and it doesn't require a JVM to run, which is probably the most fascinating thing about it. So it's ready to be working as it is, right? Everything that has to be in the application for it to work is already compiled, is inside there. So it can start very, very fast because all that heavy lifting, all that expensive operations such as analysis, optimizing the code, compiling it, that all already happened at the image build time, so that when you run the application, it can start very fast every single time. And let's look exactly how it works. So this is what is happening behind the scenes when you run your native image build process. So when you're using command like native image and give it your application, what happens is that we will analyze your application starting from its main entry point, and we will look for all the reachable code and also run initializations to try and find all the code that is necessary for your application to execute to perform what it's supposed to be performing. And then we will take only that necessary code, right? So we will eliminate everything else to make sure that your application is as small, as lightweight, and as efficient as possible. So we will eliminate all the unnecessary code and only put the code that is supposed to be there in this final executable, so that you get this very efficient image version of your application that is doing exactly what it's supposed to be doing, but doesn't have any overhead in it, doesn't have any extra facilities, such as, for example, the compiler and things like that inside it, because it's ready to use as it is. Now, another interesting thing that is happening during the image build process is something called heap snapshotting. So as we are building a native image version of your application, we are also running initializations, and we are pre-populating heap for you. So then again, you can start very fast every single time when you start executing your application, because it comes with pre-populated heap. So we basically take care of all these expensive operations and move them to the image build step. So at the image runtime, your application can start much faster. And the way to work with native image is fairly simple. So first step is where you build your native image application. So you can either produce a platform-specific native executable, or you can build a shared library. And then as a second step, you just run it as the native application. Okay, so let's say you're interested in native image, and how do you get started with it? So where do you go? What is your next step? So probably the easiest way to do so, if you want to get started with native image, is go to our GitHub repo with Crawl VM demos, clone it, and there are quite a few examples of working with different components of Crawl VM. So that's probably the easiest way if you just want to try some applications for yourself. If you would rather create something on your own, so your own application, there are a few ways to get started, but probably I would recommend going with one of those frameworks that work with native image, because that will give you a lot of features and a lot of support out of the box. So if you would rather create your own application, I recommend checking out one of those frameworks. And the first one I want to talk about is Micronaut. So Micronaut is a great framework for writing Java application. It works great for microservices and serverless, but also basically for any kind of Java application you can think of. And a great thing about it is that it's really well integrated with Crawl VM native image since day one. So if you're interested in native image and running applications on native image as a platform, Micronaut has really great integrations for it. And if you want to get started, they have this great launch page where you can configure your application, or you can use their CLI utility, which is called MN. And the interesting thing about this MN utility is that I believe it's also a Java application compiled with Crawl VM native image itself. So if you ever used the Micronaut CLI utility, you kind of have first-hand experience with native image already. And to show you some of those performance benefits I've been talking for past 5 minutes about, I have this comparison of a Micronaut, in fact, application that I have been running in a jet mode and in native image mode. And on the first part of the screen here, we see that we're running our application in 2 modes. And the application is basically a simple web server processing requests and responding to requests with the data from a list. And that's the same application. And when we run it in jet mode, we see that startup is something like 3.3 seconds. While then when we run the exact same application on native image, it starts in 170 milliseconds. So much faster. And I think you can tell how that is great for web services, right? Where you want as little work to be done while the web server is idle, right? And most of the resources or be used when actual requests arrive and need to be served. So if you want to be efficient, right, and focus on producing a valuable result and not care much about the overhead, then native image is a great deployment model for such applications. So that is startup, right? Just time it takes to start the application. But what about doing some valuable work? So what if you measured how much time it takes to actually serve first request? So do something helpful, right? And that is exactly what we are doing on the second part of the screen here. So we are measuring how much time it takes to process first request, and also how much CPU does it use, right? So what about resources usage? And we see that numbers are similar, right? So comparing to jet mode, native image is way more efficient. So not only it is faster, but also it's using way less CPU. And to illustrate that thought and look at it from a bit different angle, so here we are looking at the similar application. So it's again a Micronaut application, and we are measuring CPU usage and memory usage in the just-in-time compilation mode and in native image mode. And I think this comparison is a great, very visual overview of how native image is very resources efficient, because you see that when we are running in just-in-time compilation mode, there is quite a bit of work happening in the first few seconds. So those red spikes, that is CPU usage, right? And the blue horizontal line, that is memory usage. And you can see that CPU is quite busy for the first 3 seconds or so, because there is quite some work happening when you first run your application in jet mode, right? So classes have to be loaded, code needs to be parsed, interpreted, and compiled. And that is important for peak performance, but that takes quite some time and resources in the beginning. While native image is doing the exact same thing, right? It's the same application, but since everything has been optimized and compiled at the image build time, it's way more efficient when you run your application. Now, and especially if you're thinking or already deploying your applications to the cloud, you could be interested in how does this scale, right? So what if I want to scale my microservices horizontally? Where am I in terms of resources usage, and how does that look on native image comparing to running on the JVM? And here I have an example for it. So if you want to horizontally scale your application, native image is very efficient in a way that it's a native application, right? So things like image heap and machine code can be shared across applications, and you can see how much more memory efficient you can be if you're running on native image. So the red bars here on the chart versus running on the JVM. Okay, I've been talking quite a bit about Micronaut and how it works with native image and what you can build with it. But in fact, there are many frameworks in the Java ecosystem that work well with native image. So in the keynote, Mark mentioned already Quarkus. So that is another great framework to work with native image. There is also Helidon. And another one that I want to talk about is Spring Native project. So that is an integration project between Spring Boot and native image that allows you to use native image as a platform to run Spring Boot applications. And what we are looking here at is their results from, I believe this is Spring 1 keynote last year. And this was still work in progress. So this project is still ongoing, but you can see what great results in terms of startup time and memory usage. So what are the results that they accomplished by moving to native image as the platform? And to illustrate that thought a bit more, so this is Spring Native applications running, on Spring Native, right, as opposed to running on a JVM. And if we are looking, for example, at the container image size, you also can see how much smaller it is comparing to the JVM. And another great way to use native image and another great project that is leveraging native image is Jhipster, which is a project that allows you to easily build and bootstrap web applications and microservices. And it also now has this integration with native image that you can leverage by using Jhipster native as your blueprint. And here you can see how my application starts in something like, well, under a second, right? But I think it can start even faster on a better machine. So that is another way to easily build applications that are ready to go, and they are also very fast thanks to native image. Now, how do you make even more out of native image, right? So maybe if you want to use it in production or use it for your pet project, you want to make sure that you are making the absolute most out of it. And there are a few things that you can do. So one is you could be probably thinking at this point, so what about peak performance, right? So if we are building and compiling the application at the image build time, what about peak performance? So how do we optimize for it not having that runtime profiling information? And that is a very good question. And the way to approach that would be, we have something called profile-guided optimizations. And what you can do is you can run the application first, collect profile information about it, and then feed that profile information to native image at the image build time. So the application can be built and compiled with profiling information in mind, so aware of the runtime behavior of your application. So it can be very, very fast when you run it because we already have and use that profile information. So I will get to that in a second, but just to give you a few more ideas about native image and what you can do to optimize for peak performance with it. There are also some memory management options available for you in native image. So by default, you get serial.gc, but also we are working on advancing it in, for example, improving policies that serial.gc is using in native image. But if you want to get more options, there is also G1GC available in native image, or you can use Epsilon GC if you don't want basically to do any GCs at all. And yeah, a few more things that you can do with native image. If you would like to monitor performance of native image, we have integration with JFR, so you can use JFR to monitor and optimize performance of your native image. For that, you would just need to pass specific flag when you're building your native image, and then you can enable it and start a recording when you're running it. And then you can use something like Visual VM to observe and analyze performance of your native image application. And if you want to kind of keep reading and learning about native image, there is this article we published recently on InfoQ, where you can get a few more details about it. And in fact, there are follow-up articles from other teams in the ecosystem talking about how they leverage native image and what are the things they've learned from using it in production. So if you want some additional resources about native image, I do recommend this series at InfoQ or checking our website, graalvm.org. Okay, let me just quickly check how we are doing on time. Okay, I probably would need to speed up a bit. So what's new in native image? A couple of things that I'm very excited and that I want to share with you is that we are working hard on improving developer experience for you. And one thing we introduced in the last release in 22.1 is this quick build mode. So if you are just developing your application, you probably want to get results first, right? So build application first. And for that, we have this quick build mode. So by passing this flag, you can speed up build time significantly for development purposes, but then you would want to use normal default compilation mode for running in production because it's way better optimized for peak performance. But if you are still developing applications, right, so for development purposes, this quick build mode is great because you can get, well, your builds to be much, much faster. And on top of that, we are also speeding up the default build times. So we know that many people care about this, right? Because you want your application to build faster, to get faster results, to move faster in your development process. So we are working on that as well. And to make the image build process even more helpful for you, right, to give you more insights into what's happening, we have this new build output that shows you exactly what is happening, shows you some information about GC and memory usage. And yes, this is very helpful if you would like to understand better what is happening during the image build process. And if you're using GitHub Actions for your workflows, we also have a GitHub Action for GraalVM, so you can easily use it in your GitHub Action workflows. And as of last release, we also have Apple M1 builds, and this seems to be a very exciting update for the community. So a lot of people are excited about it. And in fact, community helped us a lot to work on this feature. So yeah, if you are a happy M1 owner, you can now use GraalVM on it as well. Now, very quickly about polyglot capabilities of GraalVM. So I said that we support all those languages, and we also support interop between them, right? So it's fairly easy if you have your main application written in Java, add some code from, let's say, JavaScript or Python to it. And the best part is that GraalVM will not only give you a platform to do so, but it will also give you tools to work with such a polyglot application, and it will optimize the whole thing for you as well. So yeah, we have a JavaScript engine, for example, and what you can do with it is that a really great use case for it is that when you want to do, for example, server-side rendering of things like React.js, you can use GraalVM as basically your main runtime, right? And if you have, for example, Java application, and then you have some React on front end, and if you want to do server-side rendering of it, GraalVM really gives you the possibility to do so because it supports both of those languages. And in fact, it supports even more, so you can use any number of supported languages in your application. So this is an interesting project of one of my colleagues from early days of COVID, where he wanted to visualize trends of how many cases are being discovered in his country. And he built that application using Java, JavaScript, Python, and used R to visualize the actual trends. So basically, you can use tools and libraries from each language to literally use the best of them and make that happen in one application. And this is an example of using Python from GraalVM. So yeah, if you want to build something like this is a recommendation system, right? So probably you want to use some libraries, let's say from Python, because there are plenty. And this is an example of Oracle NetSuite using Python libraries in their Java application and running all of it on GraalVM. And to give you an idea of what else is possible with GraalVM, so in the very beginning, I was talking about this JIT mode, right, where you can run applications with GraalVM as a compiler, and that is something that Facebook did. And the reason to do so is because they saw performance improvements of around 10%, and specifically also in terms of CPU usage, just by switching to GraalVM as their JDK. And this is an example of somebody using native image in production. So Alibaba moved their applications to native image as a platform. And here on the left, you can see that they got 20x faster compared to running on a hotspot VM. So those were massive applications. But yeah, this is the kind of speed up you can get with native image. And get started with Growl VM. So if you're wondering about our releases and release roadmap, we have 4 feature releases a year. And you can get this information about which release is coming up and what is planned on our website. That is growlvm.org. And yeah, this is where you get started, where you can get downloads. And yeah, so you can use Growl VM Community Edition, Enterprise Edition. You can download it. You can use, for example, on Oracle Cloud. Yep, so to get started, please go to growlvm.org and you can get downloads there. If you want to follow updates, we are very active on Twitter. And if you want to ask questions, we have this amazing community on Slack, or you could write us an email if that is your preference. I think that's all that I had for today. And I think I'm almost perfectly on time. So yeah, I think that's all from me. Thank you all for being here.
I feel like a kid in a candy store. I have so much to learn and do and love now. I've been a Java developer since 1998, but now I feel like I've just rekindled my love. There is so much incredible innovation on Java with Growl VM, and it makes developers' life easier and happier, and the velocity is increased. So I want to bring on Shai, who also is going to show how you can make developers' lives easier, because he's going to talk on how to make Kubernetes easier. Now, when you pair it with Kubernetes, with Growl VM, you have the ability to start up your containers in a very small amount of time. And Shai is going to show us some toolkits and technologies on how to make that easier. So, Elena, thank you so much for this. I now am going to spend a considerable amount of time following you and reading about all your incredible material on that. And Shai, over to you. And thank you again, Elena.
Thank you so much, Rory, and good luck, Shai.
Great talk. I'm very excited about Growl VM as well. And as you said, Rory, it's indeed a very interesting time and very connected to one another. So hello, everyone. I'm Shai Almog, and today we'll talk about debugging at scale in production, specifically about Kubernetes debugging. I'm assuming everyone here knows the basics of Kubernetes, so I will dive right into the basic problem description and then into the 3 tools I will show today. But first, a few things about me. I was a consultant for over a decade, worked at Sun, founded a couple of companies, wrote a couple of books, wrote a lot of open source code, and currently work as a developer advocate for Lightrun. My email and Twitter account are listed right here, so feel free to write to me. I have a blog that talks about debugging and production issues at talktotheduck.dev. It would be great if you check it out and let me know what you think. Containers and orchestration revolutionize development and production, no doubt. But in a way, Kubernetes made debugging production issues harder than it previously was. In the past, we had physical servers we could just work with, or even VPSs. Now we face much greater difficulty in this age due to 3 big challenges. Again, 3. The massive scale enabled by Kubernetes is a huge boon, but it makes debugging difficult. We need new tools to deal with the scale. We now have multiple layers of abstraction to the deployment where failures can happen in the orchestration, container, or code layers. Each failure requires a different set of skills and solutions. Tracking the cause to the right layer isn't necessarily trivial. And finally, there's the bare-bone or lean deployment problem when debugging. This is the first problem I want to focus on. We'll get to the other 2 soon enough. It's the problem of the bare-naked container. We can connect to a bare-bone container, but we have nothing to do inside it. Nothing is installed. We can inspect logs, but that relies on luck. Furthermore, if your logs are already ingested by a solution like Elastic, you probably don't have anything valuable to do within a bare-bone container. Cubesatio Debug solves these problems and can work even with a crashed container or bare-bone image. The Cubesatio Debug command adds ephemeral containers to a running pod. An ephemeral container is a temporary element that you would vanish once the pod is destroyed. With it, we can inspect everything that we need in the pod. Most changes we do in it don't matter. They won't impact the pod after we're gone. It works with barebone container. The way it does this is with a separate image. So we can have an image that includes everything in it. The container is spun from the image, that's spun from the image is ephemeral and can include a proper distro and the set of tools that we need. Cubesatio Debug was introduced in version 1.23. So if you're still in an older version, you will need to wait for that. If you use a hosted Kubernetes version, you will need to check the version used by the host. Let's start with a simple demo. As you can see, we have here a few pods. We're experiencing an issue and would like to increase the logging level so we can better see what's going on. I can use exec and log in directly to the live pod. I log in with a proper bash shell. I'm sure most of you did that in the past. It's really easy. Here I can just use standard commands like cat and grep to check logging levels. This is all good. We can see the current level is at info. Unfortunately, I don't even have Vim if I want to edit this file. Now when the container has apt or APK and when the pod isn't crashed, I could, in theory, just apt get install Vim. But that's got its own problems and is a painful process. We don't want people in production just installing packages left and right. Even if it's cleaned up, the risks are sometimes too high. Pods shouldn't be touched in production once deployed. All the information and state of a pod should be described in its manifest, unless it's a strictly stateful pod like a database, etc. So installing like this is problematic. So let's exit for a moment and try connecting again with Cubesatio Debug. I'll use the BusyBox image in this case, and we'll see how that works. Notice that this is the image referenced in the Cubesatio Debug docs. So I'm connected to the pod again, or so it seems. Technically, I'm connected to a new ephemeral container and not to the pod directly. This is an important distinction. But as you can see again, I don't have Vim or really any of the tools I would expect like Visual VM, Traceroute, etc. I can fix that. I can create an image that represents everything I need and package all of the tools I need, then pass that image to Cubesatio Debug and just use those tools. But here's the thing, I'm not unique. We're all pretty much the same. We all expect the same things in our debugging sessions. And that image I can use as probably the same image you would use too. So why not have one generic image? This is where CoolKits comes in. CoolKits was created by Tom Granot of Lightrun. CoolKits is an open source project that includes a set of opinionated, curated, platform-specific tools for Cubesatio Debug. So you can have everything you might need at your fingertips while debugging. So what does this mean? When you use Cubesatio Debug to spin up an ephemeral container, it's built using a CoolKits image. Currently, there are 4 standard images. A Go image that includes tools such as Delve, pprof, Go Calvis, and many others. The JVM CoolKit, which includes tools such as SDKman, JMXterm, Honest Profiler, Visual VM, and much more. The Node version includes NPM, NDB, 0x, VTOP, and much more. And finally, the Python version includes IEnv, IPDB, IPython, and again, much more. But this is just a tip of the iceberg, as all the versions include the many tools you would expect in any proper debugging session, such as Vim, HTOP, and also have a lot of networking tools such as Traceroute, Nmap, database clients for Postgres, MySQL, Redis, again, so much more. So let's continue from where we left off in the demo. We can disconnect the current session and then spin up a new session with the CoolKits image. Notice we can also use the shorthand KK command for many operations, which I don't use here. But you can see the syntax in the CoolKits docs. Specifically in this case, notice I used the JVM version of CoolKits, which I chose because I'm a Java guy, and hopefully so are you. But if you're using a different environment, you can use what fits here. In CoolKits, pretty much every tool I want is already pre-installed as part of the image by default. This means we can just connect and everything is already there. Since we're all pretty similar in our needs, CoolKits includes the common things most of us need based on the platform or language. It has sensible defaults and comes with Ubuntu as the distro. This is important. You have a full distribution like you would have in a desktop or in a regular server. This is very helpful for debugging. So you get everything you need, even when debugging a barebone container. Notice that thanks to Cubesatio Debug, we have full access to the main application's containers file system and the pod's process namespace. So we can do everything there while residing in a more convenient environment. It's having our cake and eating it. So to finish the story from before, I can just use Vim to edit the file and change the logging level to error, which I can then confirm using cat and grep. I can also do a lot of other things, such as profile using a profiler, debug with GDB or JDB. I can use JMX term to perform JMX operations, which lets you configure the way the JVM behaves in runtime, and pretty much anything I can do in a local machine. To give you a sense of what CoolKits installs, this is the list of packages for the JVM client. And this is bound to grow as you can all submit pull requests with your favorite packages. This is just the JVM specific image. The other images contain similar tools at similar scale. And you can get all of that thanks to Cubesatio Debug and CoolKits. What if what we're tracking seems to be an application bug? This is a common occurrence for sure. We might not know it at this stage, but that might be the place we want to investigate. We can try using logs and probably should start there. But more often than not, the issue we need solved aren't logged. We can try using various observability tools. They're great, but not for application level issues. They rule for big picture analysis and container level problems, not for application level problems. We can use one of the debuggers in CoolKits to track it. That will only work if we know the server where the issue manifested, which we sometimes do know. It is remarkably risky connecting to a debugger to a production environment. It can lead to multiple problems, stopping on a breakpoint by accident using conditional statement that grinds the system to a halt, exposing a security vulnerability, etc. JDWP is the Java debugging wire protocol. There are several such remote debugging protocols. We can use it. It suffers similar issues, but we'll dive deep into this. So here's the first problem we run into with a debugger. We can't just start using it. We need to relaunch the app with debugging enabled. That means killing the existing process and running it over again. That might not be something you can just do. Furthermore, running in this mode is a big security risk. Notice I limit access to only the local server, but still it's a big risk. Leaving a remote debugging port enabled in a deployed server code is considered a huge security vulnerability. If hackers can ride a different vulnerability, they might be in a position to leverage this from a local system. Still, if we do this for a short period of time, this might not be a big deal, right? In a different window, I need to find the process ID for the application I just ran so I can connect to it. I can now type it into the JDB command, and now I'm connected with a debugger. I can add a breakpoint using the stop command. Naturally, I need to know the name of the class and the line number, but I can set a breakpoint to stop at. When stopped, I can step over like I can with a regular debugger. However, this is pretty problematic notion on multiple fronts. First off, I'm literally stopping the threads accessing this application. That's probably not okay on any container you have in the cloud. There are ways around that, but they aren't trivial. The second problem is different. I'm old, so people automatically assume I love the command line. And I do to some degree, but I love GUI more. When I started programming, there was no option. We didn't have IDEs on Sinclair, Apple II, or PDP. But now that we have all of those things, well, I don't want to go back. I've programmed Java since the first beta, and this was actually the first time I used JDB. I'll use command line tools when they give me power, but debugging via commands, I just can't. The obvious answer is JDWP. We have a remote debug protocol that's supposed to solve this exact problem, right? But this is a bit problematic. If we open the server to remote access with JDWP, we might as well hand the keys over to the office to hackers. A better approach is tunneling. During the age of VPS, we used to just use SSH tunneling. Like this, we'd connect to a remote host and forward the port where the debugger was running locally. Notice that in this sample, I used port 9000 to mislead hackers scanning port 5005, although it wouldn't matter because it's SSH. We can do the exact same thing with Kubernetes using the local port forward command to redirect a remote JDWP connection to localhost. Port forwarding opens a secure tunnel between your machine and the remote machine on the given port. So when I connect to localhost on the forwarded port, it seamlessly and securely connects to the remote machine. Once we do that, I can just open IntelliJ IDEA and add a run configuration for remote debugging, which already exists and is pre-configured with the default, such as port 5005. I just give the new run configuration a name, and we're ready to go with debugging the app. Notice I'm debugging on localhost, even though my pod is remote. That's because I'm port forwarding everything. I make sure the right run configuration is selected, which it is. We can just now press debug to instantly connect to the running process. Once that is done, this feels and acts like any debugger instance launched from within the IDE. I can set a breakpoint and step over and get this wonderful debug GUI I'm pretty much used to. This is perfect, right? Well, not exactly. It's got quite a few drawbacks still. As we can see, there are so many problems in this process. First and foremost, the need to restart the process. We can probably run the debugger with the debugger turned on by default, but that is a huge risk. Then it's breakpoints. They break. I heard a story years ago about a guy who debugged a Rails system, and it literally fell into the ocean while he was stopped on a breakpoint because it didn't get the stop command. I don't know if that's an urban legend, but it's totally plausible. All remote debugging protocols are insecure, but I can personally attest about JDWP, which I'm familiar with. It's very insecure. In fact, there were CVEs already about products that left it open. It isn't designed with security in mind, but it's also a stability risk. Now, how many times did a debug process crash on you? Imagine adding a breakpoint condition that's too expensive or incorrect. It might destroy your app in production. Just loading the variables in the watch can cause unforeseen problems in some cases. But this is the absolute worst. Say your app has a place where it takes user credentials for login. Maybe a third-party library you use does that. You can still place a breakpoint there and steal user login details. Worse, you can elevate the permission of your own user account because everything is writable. Just set a value of a variable. This goes against privacy laws and is very damn likely. 60% of security breaches in an organization happen because an employee. There are often misconceptions of security that look at the outside world only. This just isn't true. I didn't forget about this slide. This is an even more important aspect. Everything we discussed up until now assumes we know the exact container where a problem is happening. In real life, this is rarely the case. We can have thousands of containers in real-world deployments. How can you debug something like that? The debugger can solve depth issues well. It lets us dive into code despite all of the problems, but it wasn't built for scale or for production. That's where developer observability comes in. We used to call this continuous observability, but developer observability makes more sense. It's a newer set of tools designed to solve this exact problem. Observability is defined as the ability to understand how your system works on the inside without shipping new code. The without shipping new code portion is key. With developer observability, we don't ship new code either, but we can ask questions about the code. Normal observability works by instrumenting everything and receiving the information. With developer observability, we flip that. We ask questions and then instrument based on the questions. So how does that work in practice? In practice, we add an agent to every pod. This lets us debug the source code directly from the IDE, almost like debugging a local project. To start, we need to sign up for a free Lightrun account at lightrun.com/free. Notice that Lightrun has a very generous free tier you can use to experiment with the product. Pretty much everything I show here can be accomplished with a free account, and also probably with other developer observability tools which are available. You can check out Lightrun docs for more details, instructions on setting Lightrun and Docker, Minikube, etc. Unlike Cubesatio Debug, we need to install the agent before the problem occurs. So if we do run into a problem, we'll be able to jump right into it. Let's skip ahead to a simple demo right in the IDE once the agent is set up. This is the prime main app in Kotlin. It simply loops over numbers and checks if they are a prime number. It sleeps for 10 milliseconds, so it won't completely demolish the CPU, but other than that, it's a pretty simple application. It counts the number of primes it finds along the way and prints a result at the end. We use this code a lot when debugging since it's CPU intensive and yet very simple. In this case, we would like to observe the variable I, which is the value we're evaluating here, and print out CNT, which represents the number of primes we found so far. The simplest tool we have is the ability to inject a log into the application. We can also inject a snapshot or add metrics. I'll discuss all of those soon enough. Selecting log opens the UI to enter a new log. I can write more than just text. In the curly braces, I can include any expression I want, such as the value of the variable that I included in this expression. I can also invoke methods and do all sorts of things, but here's the thing. If I invoke a method that's too computationally intensive, or if I invoke a method that changes application state, the log won't be added. I'll get an error. After clicking OK, we see the log appearing above the line in the IDE. Notice that this behavior is specific to IntelliJ or JetBrains IDEs. In Visual Studio Code, it will show a marker on the side. Once the log is hit, we'll see logs appear in batches. Notice I chose to pipe into the IDE for convenience, but there's a lot more I can do with them. For now, the thing I want to focus on is the last line. Notice that the log point is paused due to high call rate. This means additional logs won't show for a short period of time, since logging exceeded the threshold of CPU usage. This can happen quickly or slowly depending on how you're observing. Let's move on to a different demo. This is the Node.js project that implements a backend in a microservice architecture. This is a method that gets invoked when we click a movie and want to see the details. This time I'll add a snapshot. Some other developer observability tools call this capture or non-breaking breakpoint. Same thing. Once I press OK, the camera button appears on the left, indicating the location of the snapshot, like you would see with a regular IDE breakpoint. Now I'll just access a portion in the front end that triggers this code. And now we wait a second, and the snapshot is hit. So what is the snapshot? It gives us a stack trace and variables just like a regular breakpoint we all know and love. But it doesn't stop at that point. So your server won't be stuck waiting for a step over. Now, obviously, you can't step over the code, so you need to step by individual snapshots. But this has huge benefits, especially in production scenarios. But this gets much better. This was relatively simple in terms of observability. Let's up the ante a bit and talk about user-specific problems. So here we have a problem with the request. One specific user is complaining that the list on his machine doesn't match the list for his peers. The problem is that if I put a snapshot, I'll get a lot of noise because there are so many users reloading all the time. So the solution is to use a conditional snapshot, just like you can with a regular debugger. Notice you can define a condition for a log and metric as well. This is one of the key features of continuous observability. I add a new snapshot, and in it I have an option to define quite a lot of things. I won't even discuss the advanced version of this dialog in this session. This is a really trivial condition. We already have a simple security utility class that I can use to query the current user ID. So I just make use of that and compare the response to the ID of the user that's experiencing a problem. Notice I used the fully qualified name of the class. I could have just written security, and it's very possible it would have worked, but it isn't guaranteed. Names can clash on the agent, and the agent side isn't aware of all the things we have in the IDE. As such, it's often good practice to be more specific. After pressing OK, we see a special version of the snapshot icon with the question mark on it. This indicates that this action has a condition on it, and now that it's just a waiting game for the user to hit the snapshot. This is the point where you can go make yourself a cup of coffee or even go home and check it the next day. In this case, I won't make you wait long. The snapshot gets hit by the right user despite other users coming in. This specific request is from that right user ID. We can now review the stack information and fix a user-specific bug. Due to the lack of time, I'll skip metrics and many other features. There's a lot more to discuss. Let's go back to the list of drawbacks we had with debuggers and review it again. You can keep an observability agent running all the time since it's designed for this case. Here we don't have breakpoints. Snapshots don't stop. They are secure by design and are read-only. So you can destroy the server and it will throttle you if you overuse CPU. Some services use Litron's support, like Litron, support PII reduction, which removes private information from logs and block lists, which prevents a user from debugging restricted classes or files. So in closing, I'd like to review some of the things we discussed today. Cubesatio Debug made debugging crashed pods possible. It also made it possible to debug a pod based on bare bones image. Coolkits made Cubesatio Debug easier to use with pre-installed tools. Debugging an application in an existing container in production is difficult and a risky process. Developer Observability made deep, secure, read-only real-time debugging at scale easy. So thanks for bearing with me. I hope you enjoyed the presentation. Please feel free to ask any questions, and also feel free to write to me. Also, please check out talktotheduck.dev, where I talk about debugging in depth, and check out litron.com, which I think you guys will like a lot. If you have any questions, my email is listed here, and I'll be happy to help. Thank you. Well, so.
Wow, that was
I rushed.
Like I've had to manage a kubectl cluster in production, and where have you been my entire life? Where was this? That
it's 1.23. Don't forget, for the Cubesatio Debug, so it's really new, and Coolkits is even newer, and Litron is 2 years old actually. A bit sooner. I'm literally the first employee at Litron. So the whole field of developer observability.
I did a session. I was teaching some students at one of the universities in Bloemfontein. It's a small city in Johannesburg, and I lost my kube cluster, and I just lost it. It just disappeared. And right in the audience there, and I couldn't debug it, and I had no access to it, and no way to actually do that. And they looked at me and they go, No, never, no. But yeah, so this is a great opportunity to actually understand that you can actually get insight into that. So I want to bring out our next speakers who are dovetailing exactly off your talk, though. They're going to show us how to do and look at your containers and then and measure and automate the process to scale your containers, which is a very important process. So yeah, bring on Kusuma and Dinakar. And we are going to say goodbye to Shy and reach out to each other because it looks like there's so much collaboration that you three can actually do.
Scale creates bugs, and we can feed off each other.
Save us from Kubernetes of some of the issues there of losing more Kubernetes clusters than I've had warm meals. Okay, thanks, Shy. Over to you, Dinakar and Kusuma, which you've got some incredible session to show us. I had to Google exactly what a Bayesian scaling of your cluster is, though, and I felt a little bit like my Google search history was going to be confused of must, though, but it was an incredible topic. And with Shy's also topic on there, it is a great opportunity to look at Kubernetes running on Azure also and to do that. So over to you, Dinakar and Kusuma, and I look forward to your talk. Cheers, Shy.
Thank you, Rory, and definitely we'll reach out to Shy for the tool that he just mentioned. So hello, everyone. I'm Dinakar and also have Kusuma Chalasani here with me. We both work at Red Hat and look into how Java can run better in Kubernetes. And that is what we'll be talking about today. So imagine that you're an SRE and you've been given this problem to be solved. You have a complex polyglot application, such as an airline booking system that is deployed onto a Kubernetes cluster. As you can see, it has many microservices, a couple of databases. Each of the microservices written in a different language and framework. The user is now, let's say, having a slow response time while doing a flight booking. Now it is the SRE or the IT admin's job to try and make the user experience better. So if you're an SRE, you know that every runtime has many tunables. Java, for example, has maybe even 100 of them. But you also know that you're never supposed to touch them, right? Why? Because who knows what kind of an impact it has. And it has all these dependencies on other tunables, and there are just too many of them for you to manually test and figure out. And of course, now that we are running it in containers, nobody knows what happens inside of a container, right? So guess what? Most of the time, SRE is limited to tuning the app itself, or just limiting themselves to tuning the CPU and memory resources. By tuning, I mean just double the resources every time there is a problem, which is pretty much what happens with most of the SREs. So it is difficult to be an SRE, let's face it, right? You have the users bugging you for better response times. Finance wants you to cut costs always. And you have developers giving you a ton of options that you cannot use. So, well, don't worry, folks. We've got you covered. So Cruise Autotune is a tool that automates the entire process and provides a recommendation that best suits your performance needs. It's also an open source project. We are from Red Hat for All. I'd encourage you to check out our GitHub repo. So Rory mentioned about Bayesian optimization. So what exactly is Bayesian optimization, and how does it figure out here? So Bayesian optimization is a black box optimization algorithm where you have an objective function on the y-axis. That could be something like I want a better response time, or give me better throughput, or lower the cost, or even better, a mix of all of them. And on the x-axis, you have all your tunables. And so together, all of this is called as the search space. So for every point on the x-axis, which corresponds to a specific configuration, we find the result. So we actually run with the configuration, find the result. How does it do? How does your application do with that particular configuration? Find the result and plot it on the graph. So Bayesian learns from this result and gives you the next query point, right? So here the purple line is the ground truth, and the red points are the query points that is being given to you by the Bayesian algorithm. So it gives you a query point which corresponds to a trial configuration. You try that out, and then you plot the result. And then Bayesian gets better and better at predicting the next trial point. So that, let's say, for example, that you want to maximize your objective function. So that's to find the global maximum here. And so eventually, Bayesian gets to the global maximum. So that's the theory behind this. It's a very quick summary, essentially. So let's now look at how are we feeding this into the autotune architecture. So the first step here is that the SRE encapsulates all of the performance requirements into an objective function, which is an algebraic expression such as lower my response time, but also keep the cost low, and so on and so forth. So that's the objective function here in the SLO. And this is, of course, something that needs to be either maximized or minimized. And each of the variables within the objective function is now specified as a Prometheus query. And this whole SLO applies to a particular deployment in Kubernetes, which is mentioned by the selector here. So if you apply this to the cluster, which is running autotune, the autotune operator picks up this and then talks to the dependency analyzer module here, which peeks into your application through Prometheus. So it's not directly talking to your application, it's just talking to Prometheus and figures out the layers of your application. So for example, it can, your application can have Java and Quarkus or Spring Boot, or it can be a Node.js application or a Python application. And it can have many variants of Java. Like, for example, you can have a hotspot or Open J9 and so on and so forth. So it tries to figure out all the layers of your application. And then we have a bunch of tuning sets, a library of tuning sets for each layer. So Java has a bunch of tunables, Node.js and Golang and so on. And so we match the two of them together and create the search space, as I mentioned. And then we feed this to the HPO, the hyperparameter optimization service that's running here. And you can also specify the algorithm that you want to use. So there are multiple variants of the hyperparameter optimization. We by default use the TP, the tree parson estimator, the tree structure parson estimator algorithm, which then gives us the trial configuration, as I mentioned. So we take the trial configuration, and the experiment manager module here deploys that to the Kubernetes cluster, and then monitors that particular configuration come up and looks at how does it do when load is applied to that. So that is captured, the metrics are captured, and the summarized results are then sent back to the HPO, so the hyperparameter optimization service. It says, okay, so now I've got the result of the first trial, and so on. So now this loop continues, and then we do a bunch of trials, and then at the end of that, we get what is essentially the global maximum or the minimum that I mentioned. And so that goes out to the user as a config recommendation. So now just let's take a look at how this works in practice. So I have here a Minikube cluster running on my laptop. As you can see here, it has a benchmark, the Tech Empower Quarkus Rest Easy Hibernate benchmark, as well as Autotune running in the cluster. I also have Prometheus and Grafana in the cluster. And so now I'm going to apply YAML here, Autotune YAML, which says, the objective function here is to minimize response time. And response time here is nothing but request sum divided by request count. Request sum is the following query, and request count is the this particular Prometheus query. So I'm going to now just apply this here, and you can see that this starts to restart this application with multiple configs. And now we can take a look at what's going on here. So if I okay, so bring this here. So you can see that you can see the tunables that it has found. So let's take a look at the stack layers first. So here, we have this running, and you see that this is the experiment that is running. These are the layers that it found in this particular application, the Tech Empower benchmark. It has hotspot container and Quarkus, and then we have tunables, which are mentioned here for each of these layers. So we have CPU and memory as part of the container layer. I just have currently just one for hotspot, and actually a few of them for hotspot, and then a bunch of stuff for Quarkus layer as well. And the thing to note here is that I'm also monitoring the heap space as we are running this particular experiment. And you can see the results of this experiment here. So you'll see that it's running a bunch of trials. Right now, it's actually feeding in dummy metrics because this is just for the demo. So you see that there have been a bunch of trials that have happened, and so you can also look at what is going on in each of the the trials actually. So you see that each trial corresponds to a set of options that is coming from the Bayesian module, and also corresponds to a different CPU request and limit. So this happens for each and every trial that we have here. So this is essentially, this completes, and then you have a recommendation that comes out of it, which will be available as the best trial that you have here. So this is essentially a very quick demo of what we have in Autotune. So the thing that I usually talk about is that I usually compare Bayesian optimization to a Jenny. In this case, you only get one wish. You can invoke the Jenny any number of times, but each time you only get one wish. So now we need to get really creative with the wish, right? So it's something like, I want to be on a beach in Hawaii with my wife and kids and walk into my large house with this great internet connection and so on. So because you just have one wish, and so you want to try and be very careful about what exactly that you want to wish for. So I would like you to keep this in mind as Kusuma takes you through the results that we have obtained so far. So Kusuma, you want to take over?
Yeah, thanks, Dinkar. So far, you have heard the theory. Now let us look into some actual results. So I'll go through the results of the different experiments which we have capturing in the Autotune results repo. Do take a look into the results repo if you want deeper understanding of the results. And if you have any questions or comments about the results, you can always raise an issue in the same repo. So all the experiments we discussed today are run on OpenShift cluster using Tech Empower Framework benchmark. The Tech Empower Framework benchmark has aggregated benchmarks for all possible frameworks on many languages, including Java, Python, Go, and many more. So for our experiments, we are using the Quarkus REST-EZ benchmark for Java. And for the following results we are sharing, the requests and limits are set to the same. The GC policy has been fixed to the G1 GC and the max RAM percentage to 70. As many of you be aware, the max RAM percentage decides the size of heap in relation to the container memory allocated. Also, we have run all these experiments with the constant load. So there is a list of 31 tunables here, which we are using for our experiments. The CPU and the memory limits are from the container layer, and we have 25 from the hotspot and 4 from the Quarkus, which we are using. So in the hotspot layer, you can see there are both the range-based tunables as well as the categorical ones. So you can see for each tunable, what is the default value and what is the range we are using as part of which we are going to feed into the Bayesian optimization. For the range-based tunables, the initial values were chosen doing a cursory study of each tunable. And over the course of experiments we ran, and based on the results we got, we fine-tuned those ranges, which you can see in the later slides. Let's get into the results. So we started our experiments with an objective function to minimize the response time. So this experiment ran for 100 trials, and each trial uses a different configuration generated by AutoTune. The zeroth trial is the default configuration where the TechEmpire benchmark is run with no changes to the runtime configuration, and no resource requests and limits are set. And for the other trials in this experiment, the upper limit of the CPU is set to 32 and the memory is set to 8 GB. And the other tunables which we mentioned in the previous slides, it uses the same ranges as mentioned earlier. So in this experiment, you can see that we see a lowest response time at the 59th trial. And also you can see that there is no data in between the trials. That's because, so it means that the configuration failed to come up for those trials. So the failures could be out of memory, or it could be anything related to the configuration. And we are using the Optina framework as part of the Bayesian optimization, and it actually works in phases of exploration followed by exploitation. So in this particular experiment, you can see that the first 10 trials is in the exploration mode, where you can see the results vary a lot, and then it actually starts exploiting in the ranges where it thinks it can get better results based on the values of the objective function from the previous trial data. So this process of both exploration and exploitation repeats in the subset of trials for the whole experiment. So for the full results, you can actually look into the experiment 4 in our AutoTune results repo, which we have mentioned. So you can see 60% better response time and 19% better throughput in this configuration, but it has come with the cost of higher CPU. So you can see the CPU usage is higher in the AutoTune config compared to the default config in that page. So, and for each experiment in our repo, you will find few files where you can get the detailed understanding of our results. So the experiment data.csv is the file where we add all the raw data related to the trials in the experiment. And the benchmark YAML has the configuration used for the benchmark, which includes the list of all the tunables we are using along with the ranges, and then the repos used, and what's the load we are using. So it has all information about how we are running the trial. And the next one is the best result config YAML, which contains the best configuration generated by AutoTune in an experiment. So as we have seen in this experiment, we see a higher CPU usage. So it's time we have to tune our wish again. So now this time we became a little smarter, and with this we thought we have to restrict the resources this time. So now instead of using the whole course available like earlier experiment, we are restricting it to use the 4-core 4 GB. And to mention, there is no relation between our previous experiment data and this experiment because we ran it on a different hardware. So, but you can compare the defaults with all the trials in a particular experiment. So this experiment also ran with around 100 trials. The default config in this experiment uses the CPU request and limit set to 4 core and the memory request and limit set to 4 GB. And there is no change in the runtime configuration. And as you can see, the lowest response time in this particular experiment is observed at the 64th trial, which is 1.82 milliseconds, and the default is with a 5.01 milliseconds. And you can actually see the similar behavior of the exploration and exploitation, which we were discussing in the earlier experiment. So you can see the first set of trials it has explored a lot, where you can see all the results are getting varied a lot, and then the next set of results where are within the same range of the data, and then the exploration and the exploitation. So if even with this fixed resources, after we have set the resources to 4 core 4 GB, we still see the better response time, which is 64%, and we do have a 6% better throughput as well. And you can observe from the results repo, which is experiment 6, the CPU usage is almost similar to the default one with the config. So we have so with this, we can say the cost is almost similar between the auto-tune config and the default config. So can we think like we got everything what we wished for? I can say yes. But did we wish for everything what we wanted? So I could say no. That's because if you look into the data closely, we are seeing a very high tail latencies. So now again, it's time to tune our wish. So this time, the wish is like we want to keep the cost the same and give me the lower response time and high throughput, and also keep our tail latencies lower. So for this, we added a few weightages to the metrics as well. So by giving priority to the response time and then the throughput and the max response time. And again, as I mentioned earlier, there is no relationship between the previous experiment and this experiment, as everything was run on a different hardware. So the 0th trial again here is the default config with CPU and memory requests and limits set to 4 core and 4 GB. And there is no change in the runtime configuration. And in this experiment, we see that the lowest response time is observed at the 97th trial, and where the default, which is around 2.39 milliseconds, and with the default being 14.21 milliseconds. So we did see a better response time, which is around 83% this time, but with 1.3% better throughput, and the latencies are way lower compared to the earlier results. So you can actually look into the repo for detailed information of the results, where you can get the charts for every metric available. And we can say now we finally got everything that we have asked for. But more importantly, we asked for everything we wanted, being cost being almost the similar, and then better response time with a good throughput and the very lower tail latencies. So now we actually calculated the cost of the hardware. So by exploiting the data we got from the previous experiments for both the default and the auto-tune configuration. So we did measure how many instances it would take to handle 1 million transactions, and applied it on to a matching AWS configuration, which is an extra large, which has 4 core 8 GB. So we observed with the auto-tune config, there is an 8% reduction in cost. So with the auto-tune config, it performed better both in the performance metrics as well as the cost. And here is the next slide, please. So here is the best configuration for our take 3 experiment, where we have better response time, throughput, and the low tail latencies. So you can see that on the right column is the value for each tunable, which we got from the auto-tune. And the ranges in the bold are the tuned ranges based on the results of the previous experiments. And interestingly, the auto-tune has flipped some of the defaults for the categorical ones, which we showed it in bold, where it gave the best configuration. So this had some conversations in our in-house Open Jdk team, and we have the discussions available in the repo as well. And we welcome your comments on the same in the repo. And as an extension to the previous experiment, we did another one where CPU and memory were kept constant, and only the other 29 tunables were used to optimize. So this experiment mainly highlights the benefit we get by tuning the JVM parameters and the Quarkus tunables. So we did observe around 81% better response time again, and where the data is available in the auto-tune results repo in the experiment 12. So this time we collected the percentile information along with how many requests were served within a specific time. So this data shows that in the default config, you can see that only the 5% requests were handled within 1 millisecond, and 60% were within the 10 milliseconds. But in the auto-tune config, you can see 78% of the requests were handled within 1 millisecond, and 16% in the 10 millisecond range. So this shows that the configuration generated by auto-tune So 95% of the requests were within the 10 milliseconds, whereas with the default, it's only around 65% of the requests. So we are doing multiple experiments, and we do have multiple experiment data available in our repo. You can actually go and look into the results and comment on it. And the other new part which we are doing currently is, as there is a lot of buzz in the community regarding the GC policies and the appropriate resources for that, we are looking into the particular problem and ran some experiments on the same. We do have some initial results in our repo, and you can actually check it out in experiments 13 and 14. Over to you, Dinakar, to take through HPO.
Thank you, Kusuma. So now I just wanted to mention that we are working towards releasing a AutoTune MVP shortly. It should come out hopefully by the end of next month. However, we do have something that you can try out right away. So if you remember the AutoTune architecture, we had a HPO service that was running here that was providing the configurations. So what we have done is to take that out of AutoTune and run it as an independent service. So this is available in the cruise/HPO repo. So HPO can be run right on your laptop, and it provides a simple REST interface. And we also have a gRPC interface as well to be able to access this service. We also have a couple of demos that are running, that you can run. So it's available here in the Cruise demos repo. So you can see that there is a HPO demo setup here. The one that I showed you earlier was actually this script, AutoTune minikube demo setup.sh, and you can run the HPO demo using the HPO demo setup.sh. So actually, the HPO can, and with just the HPO service, because it can run right on your laptop, it'll make it really easy for you to try this out. And it's not tied to Kubernetes in any way. It can be run natively as well as within minikube as well. So it'll make it easier for developers to get their hands on HPO and try it for all kinds of use cases that we can think of. So just a quick word on all the repos that we mentioned today. The project is github.com/cruise, under which we have all the repos. AutoTune is cruise/AutoTune. Demos are available in cruise-demos. HPO is cruise/HPO. Results that Kusuma was talking about is in AutoTune results repo. And the benchmarks repo is where we have aggregated a few of the benchmarks and basically made them YAML friendly and so on. So it makes it easier for us to run the experiments that we have. And we would love to hear back from you. If you have any comments and questions, you can post them on GitHub directly. You can also join our Slack, as it's mentioned out here, or you can even send us a mail at cruise@redhat.com. So we would love to hear back from you and look forward to collaborate with all of you. Thank you so much.
Wow. Okay. I apologize upfront to any container that I've offended in the past, and I should have actually run this tool set and understood this before I actually size my container. To me, it's how much memory you have in the classic Java developer, all of it, all of the time. And I'm learning about using code spaces around how you need to have such a fine-tuning understanding of your container, of your Docker container, and your Kubernetes cluster. I need to do a lot of reading again to understand all of the metrics that you put up there. But it's great to actually show that there is a body of information already there that you can actually go in and choose your container and also your size it quite well. Brilliantly done. I'm going to bring in Patricia here to do the changeover for your talk. Thank you, Dinakar. Thank you, Kusuma, for that excellent talk on how to scale your containers. And Patricia is going to take a little bit of a different look at technology around that. And I always say to myself, Rory, don't ever offend anyone who has a talk with the word hack in the title, because they know a lot about you already. So I don't want to be hacked, Patricia. So I'm going to say right up now, XSS is one of the main concerns that I have always when I'm deploying a website. I use CodeQL to do that. So Patricia, I'm going to hand it over to you. Thank you, Dinakar. Thank you, Kusuma. And I look forward to your talk.
Hello, everyone. Great to be here. And my name is Patricia Węgrzynowicz, and today I'm going to tell you about XSS injection and how to use it to, for example, do phishing attacks or hijack victims' sessions. Briefly about myself, I've been doing professional software development for over 20 years. Most importantly, I founded Yaml Labs. That's a startup where I work on automated detection and refactoring of software defects, mostly security vulnerabilities and performance anti-patterns. So basically, security is my daily job. What am I gonna show you today? Basically, after brief introduction to XSS, I will focus on 3 demos. And I want to show you XSS in practice, just for you to feel it. So let me start with explaining what cross-site scripting actually is. Actually, cross-site scripting is a kind of injection attack. It happens basically when malicious scripts are injected into otherwise benign and trusted websites. Usually it means injecting JavaScript or some HTML code. Why does it happen? Because usually in our web application, we don't have proper input validation or output escaping. Basically, XSS made it to top 10 OWASP security vulnerability risks. And it's been on the list for many, many years. OWASP stands for Open Web Application Security Project. That's a non-for-profit organization which aims at increasing awareness of security among developers. And every couple of years, they publish top 10 security vulnerability list, and most recently it's been published in 2021. And as you see on 2021 list, we have a more general class of attacks like injection, and it covers XSS. We have like a combination on a more general injection and more specific XSS from 2017 list here. What XSS and how dangerous XSS is according to OWASP. Basically, XSS is very easy to exploit. It's a very popular but easy to detect security vulnerability. And what is the impact of XSS? It depends. Technical impact itself is like medium 1, but combined with other security weaknesses in your application, it might be very dangerous from the business point of view. So I would like to keep this introduction to XSS very brief and simple, because the fun part of today's talk is to how can we exploit XSS vulnerabilities and how dangerous they are in practice. So a couple of slides about different types of XSS, just for you to have a basic understanding. So basically, there are different classifications of XSS vulnerabilities. The most popular one is to distinguish three classes of XSS attacks or XSS vulnerabilities, rather. Stored XSS, reflected XSS, and DOM-based XSS. Reflected XSS happens when injected script basically is in URL, and then a web server reflects it off to the response. So it's delivered to a victim via link, via other web page, and links in those web pages, and that's kind of attacks. In case of stored XSS, this one is more dangerous because basically malicious script is permanently stored on a target server, like in a database, for example. Usually, it refers to some sort of visitor logs, forums, comment sections, etc. So a victim is prone to an attack via just regularly browsing web. In case of DOM-based XSS, we have attack payload executed as a result of DOM updates. So this one is very difficult to protect against. In my own classification, it's better to focus on two orthogonal axes of XSS attacks, where data, one axis is where data is persisted, and the other one is where untrusted data is being used. So if there is no persistency, data persistency, no, so that's like stored reflected XSS. If the malicious code is being stored, it's like stored XSS. And we have server and client sides where XSS is actually being executed. For the first demo, I will ask you to go to https://demo.yonlabs.com. I will post links on my Twitter account named YonLabs. So please go there and observe some incoming messages to show URLs. The first one will be simple reflected XSS, and I would like you to observe how your browsers react. One more thing, don't include any confidential data during this demo, because it might happen that I will hijack your account or your web page. So be careful and don't put any real usernames, any real passwords. Just use some fake ones for the demo purposes. So let's go to the application and demo. I will post a link on Twitter. That's gonna be our first demo. We have a simple application with just like public comment section, and we have only one field, so that's suspicious, and most likely we have an XSS vulnerability here. So let me show you vector attack. The goal of this attack is just to display alert with XSS string. With most of injections attacks, we need to adjust some boilerplate to actually make the engine execute our code. So here we have like closing of a tag, and here we have like opening a new tag just to inject in the right place. Let me copy this one and let's switch to our vulnerable application. And what happens when I fill this comment, this edit field and filter? Yes, we have XSS alert popped up, but it depends. We can basically we can show this alert by filling out edit field, but also as this is like a get method and get requests, I can post entire real link with URL encoded attack. Okay, so you can try it yourself and see how your browsers will behave. And basically, the behavior of browsers differ. Sometimes, and for most browsers, an alert window will pop up. For others, like Safari, nothing happens. Why? Why so different reactions? Because some browsers use XSS auditor filter and some don't. So for example, Safari uses XSS auditor filter and by default it's active. On the other hand, Google Chrome deprecated XSS auditor in 2019. Firefox doesn't have any XSS auditor filter, so just interprets pages as they are. Why Google Chrome deprecated XSS auditor? Because XSS auditor filter produces a lot of false positives. So it may happen that a valid page is not properly displayed because some parts of it are sanitized and basically removed from being displayed. So because of a high rate of false positives and because it's relatively easy to bypass XSS auditor, that's why a lot of browsers retired the filters or didn't have any interest in implementing some. Let's take a look at Firefox browser and how it behaves in our case. Nothing happened. Let's take a look at JavaScript console, and you can see that XSS auditor refused to execute a script here. So that's why some browsers don't display this pop-up. Only a year ago, it was very simple to bypass XSS auditor used in Safari. It was enough to, instead of an alert, to put our alert code in a script and download the script. And that was it. That's not working anymore. So XSS auditor in Safari is being actively developed. However, there are other ways to bypass it. So basically, it's not recommended anymore. Instead of using XSS auditor, it's better to use content security policy. A couple of years ago, it was popular recommendation to use XSS protection header, where once it was set to 1, it forced XSS protection and usage of auditor filter. So that's not a valid recommendation anymore. We will learn more about content security policy later on. And now, just for all of you to have more fun with demo, I will switch to disabling XSS protection. And in such a case, XSS alert is properly, from the hacker point of view, displayed with Safari as well. So now it's time for our second demo, and this is going to be phishing. Let me switch to actual attack vector. Again, I'm downloading phishing JavaScript from Evil names from Evil server, and basically executing the phishing script. What's going to happen? The phishing script basically overrides, in our case, login register page. And instead of, it uses the original code, but it replaces all action in forms with this with this action, which basically is sending. So instead of sending a form to a correct original server, the form will be sent to our server, which just stores down all information. So let's give it a try. And how does it look like? Let's switch to Firefox. And what happens when I insert my malicious JavaScript, malicious code into public comments and filter? Basically, we were redirected to this page. It looks like a valid login page. However, it's not. Once I put here username and some password, you can see that the response from the server is different, because this was the actual response from our hacker server. So basically, my username and password have been sent to hacker server. So that's a way of phishing when basically you replace the original web page with some malicious web page, usually redirecting users' actions to some hackers' servers and resources, just to, in this case, grab all usernames and passwords. So that's another demo. So in case if you would like to use it, I've prepared this malicious URL, and you can try it yourself. I will post it again on my Twitter account. and give it a try. But be careful and don't put any real usernames or passwords. So that was a phishing attack with very, very high impact because usernames and passwords can be stolen. Now I will enable comment section, and I would ask you to log in, to register, create new account, and see what's gonna happen. I'm going to show you stored XSS this time. Okay, so switching to my server, I will enable comments. I didn't want you to mess up with my demos, so the comment section for adding new comments was disabled. Now, once you register and log in, you should see new comment section when you can basically add new comments. So I encourage you to add some comments, and I will add one myself. This one is for stored XSS. So basically, this is going to be very simple. That's another script. And this script just loads an image, and the URL of an image is basically sending your cookie to hacker server. So let's give it a try. JDConf is awesome. That's my main command, but I will add some extra information here. And here it is. It looks completely innocent. However, when we take a look at page source, we can see that the script is actually here. And every time you enter this page, in the background, the browser will send your cookie to my hacker server. So my kind request to you now, just go to this page and refresh it. And what I do is I will start observing logs. Or actually, that's another way which I prepared for you to see logs as well, is just go to the hacker server and access stolen path. So we see that a lot of information has been stolen. You can observe it by yourself. I will post this link as well. And we can grab some cookie and basically hijack a session. So what happens here? Now I will log in as a demo user. That's Firefox. I will use Cookie Manager add-on in Firefox. That's a very nice add-on to manage cookies. And simply I can replace my original cookie with stolen one. I can save it and refresh page to see which user I'm impersonating now. So you see that was my original cookie from a different browser. Let's give it a try once again and try to catch another cookie. Let me refresh it. So we have some other cookie here. Maybe that's gonna be for different user. Again, I'm switching to Firefox and using Cookie Manager to change my cookie. And voila, that's artificial idiot. Yep. When you browse a web, you need to have some basic understanding of security. That's right. So basically here we've seen exploitation of weak session management. The original vulnerable application didn't use any cookie flags like HTTP only. HTTP only blocks access to cookies from JavaScript. So that's like basic security hygiene to be used by developers for the web applications. Another best practices for session management include random unpredictable sessions, some secure transport, storage, avoiding mixing HTTP and HTTPS. What happens if you use HTTP only and we can't steal a cookie? It looks like we can still use it because when we have an XSS in our application, we can basically force a victim to do an action as a prepared and forged by a hacker. And with XSS, any anti-CSRF protection doesn't work. In case of technical impact of XSS, you've seen session hijacking. We can scrape some sensitive information in very similar way. You've seen phishing. We can post data on someone's behalf. We can use malicious redirecting to send a user to a spoofed login page. We can use social engineering to download and open a file in that way, compromising the entire victim system. So it might be pretty dangerous. Fortunately, most modern frameworks provide very good defense against XSS. We have strong, we have input validation, we have contextual escaping, so that's very good. And that's not a simple thing, because if you take a look at those recommendations from OWASP, how to do proper contextual output encoding, it takes a lot of knowledge to do it properly. But is it enough? Unfortunately, no. Those XSS defenses are pretty difficult to configure. So from time to time, it still happens that modern frameworks have security vulnerabilities. So we need to be careful and include some extra anti-XSS rules, like implementing content security policy. Basically, with content security policy, we can block loading of resources from unknown sites. So we can limit, for example, scripts only to be downloaded from our original domain. So that's a very important anti-XSS rule. And the general advice is never trust user. So be wise and use your tools properly. And the answer to this is like continuous learning. As developers, we must keep educating ourselves. So thank you for your time, and you can find more resources on my GitHub, and you can reach me via email or Twitter.
I can't believe that you did live demos there and you got people to actually hit that URL and then you left it on there. Nothing goes right when you actually ask people to hack you live on air though, but it worked well. And I'm going to go rewatch those demos there because I've got some websites that I've hosted on Azure, but I didn't do all of those things that you mentioned there. And I feel a bit embarrassed then to go back there about that. And I've used CodeQL to go and scan for for XSS, and it's alerted me to a lot of those issues with CodeQL. That's GitHub Advanced Security. And I've also used WebGoat to actually go in and try and learn that though. But what you showed me today goes a little bit more deeper into how to prevent, how to and analyze, and then how to actually make sure that you make your users aware of the cross-site scripting. So I've got Martin Lippert, who's also, I'm going to bring him on here. And then I'm going to say goodbye to you, Patricia.
Hey.
Thank
And
you.
it was a great call, but I'm scared now. All of these talks that I've had here, and I just have to go back and I'm going to, give myself a hug and say, okay, Kubernetes, XSS. But Martin's got a really nice talk on basic scripting tooling. You're not going to show me how to get hacked, right, Martin?
No hacking today.
Your Patricia's already kind of scared me with that. So thank you, Patricia. I'm going to hand it over to you, Martin, and I look forward to your talk on Spring Tools with Visual Studio Code.
Awesome. Thank you very much for the introduction. And I'm very happy to be here. So thanks for inviting me to talk to the audience and give a presentation about Spring Tools. So my name is Martin. I work for VMware. I work on the core Spring engineering team. And the stuff that I'm working on is tools for developers. So my team is doing all the Spring tools for Eclipse, the Spring tools for VS Code, and other tools. But what I really would like to achieve is to make you as a Spring Boot application developer more productive using the tools that you like and that you love. So that is why I'm standing up in the morning and thinking about and hacking on tooling to actually make you more productive. And in this session, I would like to show you what we did for Visual Studio Code to actually turn that into a real awesome environment to implement and hack on Spring Boot applications. Since talking about tools is not so much fun, I will jump to live demos and show live demos only. Hope that's okay with you. So let's go actually to VS Code. So I have a, let's say, more or less standard VS Code installation over here. But in order, if you want to implement or work on Java and Spring Boot applications, I would like to recommend to install a few extensions. So the first one, and this is probably the most important one, is you should really install the extension pack for Java. That's a well-curated set of additional extensions to make or to turn Visual Studio Code into a great environment to implement Java stuff in general, to debug and run Java applications, test Java applications, have additional support for Maven projects, look into project definitions, and we will see all that basically in action. So I have that installed already. If you want to implement Spring Boot applications, I would also like to really strongly recommend you to install the Spring Boot extension pack in addition to the Java extension pack. This comes with the standard Spring tools. That's the stuff that we work on. The initialize integration, so kind of a start.spring.io within your VS Code environment. That's done by our colleagues in Microsoft. And some other interesting stuff that I will not go into the depth today of the dashboard, because there's so much stuff that's going on behind the scenes to improve that this is probably a good demo for next time. So I have those things installed. And once I have those things installed in my VS Code and I go to my get started thing, there is a little nice additional walkthrough showing up here, telling you a little bit about how to get started implementing and working with Spring Boot applications inside of VS Code. So you can look at that, get an idea about where to start and what to do. So usually, if you want to start hacking on Spring Boot applications, what do? Of course, you go to start.spring.io and you create a new Spring Boot project. You select something from the metadata, implement some or define some project metadata like the names and so on. And then you select the dependencies like, oh, let's walk through that, use the web dependency and so on. And then you maybe kind of explore what start.spring.io would generate for you. You can see what's there, you download, you unzip, and then you maybe import that into your IDE. But the good news is you can do all that directly from within Visual Studio Code. So in order to get started, you can either click this nice button on the walkthrough, but there is just, if you open up the command palette and type in Spring, you will see some Springy content showing up there. And one is the Spring Initializer actions. Among them, you can create a Spring Initializer project as a Maven project. You can also switch to a Gradle project, but I will do the Maven project. So let's get started with that. It prompts me for all the metadata that you would see on start.spring.io as well, and ask me for kind of the values and give me kind of quick picks for things that are available. And behind the scenes, this is all coming from start.spring.io. So whenever something new comes up at start.spring.io, you will see it in your VS Code automatically for you. So don't be worried. This is nothing separate. This is just a nice integration. So let me select this in Java, of course, and some default names. Package as a jar. I select the Java version 11. And then you can browse through the dependencies and through the modules that you want to include. So for example, search for web and say, oh, let's use the web one. I also want to use the Spring Actuator one because that allows me nice additional features. So once I have those selected, I can just press enter and it will create the project. It asks me where to store the stuff. Let me select the Spring demo, generate this into this folder. And once that's done, it asks me whether you want to open a new VS Code instance to only look at this project, or if you want to add this to your existing workspace, if you are in an existing workspace, which I am, because I have a little additional demo project prepared for you. But let's continue on this generated one. So I add this to my workspace. It shows up over here in my file explorer. I can see the demo thing, and I can directly see it's all there, right? Ready to use, simple generated Spring Boot project. And as you can see over here is that, let me look at my notes. It is already importing this project as a Java project. So you can do all the Java coding inside of this. One thing, for example, is you can take a look at the outline. You see the regular outline of this class. Nothing really super fancy in here because it's such a small class. Some small things from the Spring tools you can see already shining through here. We will talk about those things in a moment. But I think more interestingly for a Java project is that the Java Project Explorer allows you to really walk you through all the elements, especially all your Maven dependencies, for example. So you can see all the resolved Maven dependencies. You can dive into those libraries. You can click on the class and see the source code, all the stuff that you're probably used to from other IDEs. You can do that in VS Code as well. You can look into the JRE, take a look at all those classes and stuff like that. So it's all well integrated, and it feels really like a real great Java environment. So let's do something. Let's hack a new controller because my generated project contains really no real functionality. So let's do a myController.java class, and it knows, oh, it's a Java class, so it already gave me the option to edit some code snippets in here, so I can work on that. Class is okay. Let me do a REST controller thing over here. So you see it already shows up contenances pretty quickly for the regular Java stuff. That's a REST controller. Yeah, REST controller is great. And once the tools recognize that this is a Spring REST controller, and I open Content Assist in here, it opens up additional snippets that are probably useful if you implement a REST controller. For example, you will most likely want to implement get mapping, post mapping, put mapping things. So let's do a get mapping. Adds you a little snippet in here that you can change. Let's say we do a hello thing, a very simple one, and we return hello JDConf in here. So that's basically it. I already implemented my first Spring Boot application with the REST controller. You can see regular Java tooling kicking in, saying this import is no longer used. If I click on that, I get additional actions, for example, to organize my imports. So it's a Java well-aware environment that can do all this stuff. In addition to this pure Java tooling, you will see that the Spring tools behind the scenes already are looking at your source code and extracting additional Springy information out of them as so-called symbols. So in this case, it shows me that there's a bean that's being defined, and there's request mapping being defined. The request mapping is /greeting. So this becomes specifically handy if you want to get an overview about what is in your file from the Spring perspective. So if I open up the go to symbol and file dialog and press add, it kind of filters down the list to all the Springy elements in this source code, where I can see, oh, there's a bean definition. In this case, it's a REST controller, and it's a request mapping. Once we arrive at a more complex example, you will see a lot more of this, and I will show you a lot more of that stuff, which I think is really, really awesome. Okay, so we did our first kind of little REST controller. That was easy, that was quick. Let's try to run this. So I can just create a launch configuration for my little demo project. So it generates the basic launch config, figured out that my main class is over here. So I can just go in here, select this launch configuration for my demo application, and press run. As you will see, the regular Spring Boot application startup logging is going on here. You see it started up. That worked nicely. And I can go back to my source code, for example, and you'll see some additional information showing up that the Spring tools infer from the running application for you if you have the Spring Boot actuators on the class path of your project. So that is kind of a requirement for, not for the Spring tools in general, but if you want to extract additional information from the running application and show that in your source code, which I do in this case. And the nice thing about that is, if there's a request mapping that is live, that is available, it gives me this code lens, and I can just click on that. It jumps to my browser and opens exactly that request mapping, and I see hello JDConf. So that's awesome. Just a quick, nice way to help you navigate and try out those request mappings and see what is actually active. We will talk a little bit more about the other highlights in a second. Of course, I could also do something like debug. So if I do the same, it jumps on to this line, stops at the breakpoint. I can see what's going on here in my class and do all the stuff that I'm usually familiar with using source level debuggers for Java. So good stuff. Let me deselect that and continue with that. So that's running the application. Let us stop this Spring Boot application, which was basically kind of in a few minutes from nothing, having VS Code installed, install the extensions, create a Spring Boot application, hack a controller, run and debug the controller in just a few minutes, which I think is pretty good. It's pretty reasonable experience and provides you kind of a great step into an application. There is another thing, of course, that this generated Spring Boot application has. It has tests. In this case, there's a very simple test. And there's test support in VS Code for Java applications. So you can just run those tests with this little test run over here. And you see, oh, it's running the tests. A few tests have passed. And you can take a look at what happened. Everything is green. That looks good. So let me try to change that so you can see a little bit more fancy stuff. Maybe probably a test that fails. You can see all the content assist stuff going on here. That looks fine. Let me rerun the test case again. And the cool thing is, once it ran the test and something failed, it shows me kind of embedded in my source code directly what happened. So you can see here, oh, expected true, actual was false at this line in this test case. So let me quickly kind of fix that again. You can directly change that. Let me rerun the test again. And you'll see, should run again. Yeah, perfect. Everything's green. That looks great. As you have seen, these code lenses that show up once the app is running can be quite handy, especially in the case where your app is not running on the default port. You don't want to go to the browser and type in localhost and then, oh, guess the port and things like that. So let us do something like this. Let us change actually the port of the application. How do you do that? Usually you go to the application.properties file where you can define all the various properties of Spring Boot and beyond. And that's a huge set of properties. And usually I don't remember them all. So I need to walk through the documentation and look them up or try something out. But the Spring tools actually do that for you. So when you start typing, they give you content assist. They give you content assist for what are the defined properties that are available from Spring Boot. So let me, for example, do something like server.port. Shows me server.port is available. Oh, there are other things. You can see the strike through ones. Those are deprecated. You should avoid using them. And if you continue to use one of those, you will get a nice warning saying this is deprecated. You should not do that. So let's switch to the port and type in something like hello, which is of course obviously not really a valid value. So the Spring tools provide you real content assist and validation for those property files. So when you hover over, you will see it is expecting an int, and if you hover over the key of the property, you will see actually a little bit of explanation about what this key is about. So it is about the server port. Default is 8080, so let me do something like 808081 here. Go back to my controller. Let us run the application again to see what's going on. Oh, there's some problem going on here. I maybe need to clean the cache. Let's restart and clean the cache and launch the thing again. Let's see if my lovely code lens appears, which I hope, with the changed port on this code lens. So it's resolving the launch config, starting up the debugger. At least I hope it will do something like this shortly. We'll run the Spring Boot application for me and shows up the new code lens with a different port, and I can jump to that. So just a nice validation of how useful those code lenses really are, because I really love them. I like them so much. So let's jump over to something a little bit more complicated, something like Pet Clinic. A cool thing about the Spring tools is that they look at your source code and they analyze your source code and they understand the source code from a Spring perspective. So you've seen this little kind of helper symbols on the file so that you can get an overview about the file. You can not only do that on a file base, you can also jump to the search for symbols in the whole workspace. So if I do that with kind of Command T here and press Add to filter that down to the Springy ones, I see all the Spring symbols from all the projects in my workspace. So for example, if I'm looking for something very Springy specific, like a Spring application, there must be something called Spring application as an annotation. I see, oh, it filters down and shows me those are the two beans that are defined with an application, with an annotation, Spring Boot application. And this is quite handy to actually jump around. So I can quickly jump to my Spring Boot application. And if I have multiple applications or multiple configurations, multiple controllers in my project, in my workspace, I can super easily and super quickly jump around them. So let us do that again. I would like to see something that is a controller. It shows me all the things that are that have a controller in the name, or the annotation or an annotation controller. And even if this would not be called my controller, it would recognize that the REST controller thing inherits from add controller. So for example, if I do an add configuration over here, it knows that certain beans like demo application and pet cleaning application, those beans actually inherit the add configuration, or in this case, add Spring Boot configuration annotation. And that shows the stuff here for you up as well. So you can easily see, even if you don't use exactly this annotation on your class, but maybe a more specialized one, it will still show up here. So you can get a super nice overview about what are all my components, add component, even though maybe the class has an annotation called add controller on it and not add component. In addition to that, we also identify specific Spring elements, like all the bean definitions. What are all the bean definitions that I have? Also all the implicit ones via specific annotations. So you get an overview about the beans. And if you look, for example, let's say I look for something like a bean that had something with repository on it, I super easily get an overview about all my repository beans, or beans that are called repository in my workspace. Can also, for example, look for, is there maybe something like a data source? Oh no, data source is defined over here, at least not in this way. And the other cool thing is that with @/ you might have already seen that it extracts all the request mappings from my application. So I see an overview about all the request mappings in my Spring Boot application, and I can easily jump to them. So in this case, I would like to go to the welcome one and see what is going on here at this request map for the welcome one. So let me start up my application again. Spring Pet Clinic one. Let's try this. It starts up. It also has actuators on the class path. So I would expect some additional information showing up here, for example, to jump to the home page, to this request mapping directly, which is great. But you also see these green hovers over here. And they show additional information about these annotations and tell you what is going on with this annotation at runtime. So not from the source code perspective, but from the runtime perspective of the application. In this case, it shows me this request mapping, this get mapping annotation is actually available in this process when you hover over it under this URL. So this is great, right? The controller, if you hover over that, it shows me this bean is actually active. This bean exists at runtime in this process. Some other thing is there's an auto-wired annotation over here. And this set is required false. It needs a welcome message provider, and this is not highlighted. So that means this auto-wired thing is not fulfilled at runtime. There is nothing being auto-wired in here, at least not yet. So why is that the case? Let's try to find out. Maybe we have something like a bean that we expect welcome provider, welcome message provider, something like that. Welcome message provider. Here's a welcome message properties thing. Here's a property-based welcome message provider. That looks interesting. Let's take a look. That's what I would expect to show up here, really. And it shows me the class. I can easily jump to that. And the add component annotation is not highlighted. That means this bean is not active at runtime. This is what we expected from the auto-wired annotation. So it seems like something is missing here. And if I hover over this conditional annotation, I will get additional information saying, oh, this condition is not fulfilled. Why? the conditional on property did not find the property pet clinic as one message. This is the reason why. So let's go back, of course, to the resources and see what's going on in my properties. Why the hell is this property not there? Oh, I put that in comments. So let's save the file. You see under the hood, this updates the running Spring Boot application because we have Spring Boot DevTools on the pet clinic as well. And if I go back, it's still the same. Why? This live information needs to be refreshed. So the application started under the hood. Let's refresh that. So we can go to the command palette and see this live information coming from a different from processes and being merged into the source code. You can actually take a look at that and see what's going on there via manage live Spring Boot processes. And there you can see there is a connection to the process called pet clinic, and you can disconnect from that. So forget about the live information, or you can refresh that. So let me refresh that information. And that grabs new live information from the app and displays that. And now we see this component is active. This is great. This component is active. This component is being injected into the welcome controller. So we see the wiring between those components that happen at runtime in Spring Boot when it creates the beans and wires them together. We see the result directly in the source code in the IDE here. So we see this component is injected into, this is what this arrow means, injected into the welcome controller. And another bean, the welcome message properties, is injected into this component via this private final field here. Well, maybe it's not the best way to do that. You know, field injection, not awesome. We should change that in the future here. But you can see this information, and you can see where stuff is coming from and where this is being injected into. And I can, of course, just navigate to that. And then I see, okay, this is being injected into here. And of course, you see here the other way around. The other bean is injected over here. And you see the auto wire is being highlighted and things like that. So you really get a good understanding about, or a better understanding, what happens at runtime with your Spring Boot application, and compared to what is in your source code. And we make it easier for you to bridge this gap between what's going on at runtime and what do I expect? Is it really the stuff that's going on there? And what's going on in my source code? How did I write the application basically? And how does that all fit together easily? And this is really cool. The cool thing about that feature is also that you can connect to multiple running applications. So if you have multiple instances running locally, or for example, you have one application running locally, and you have the same application running deployed onto your cloud or whatever, you could do something like connect to both. And it would tell you, for example, here, okay, this thing exists locally in this process, but it does not exist in the other process. So you can also compare two different running Spring Boot applications in terms of, or two running instances of this application. How do they behave, and why do they behave differently maybe when they run in different environments, which I think is really, really useful. Okay, so this kind of is a super quick walkthrough some of the features of these Spring tools in VS Code, and I think demonstrated well that you can do real serious Spring Boot application development using VS Code as a great IDE for hacking on Spring Boot applications. And with that, I would like to finally jump back to this slideshow and show you one more slide to just remember and give you a few resources, what you need to do. Remember, if you have VS Code installed, you should go to the Java extension pack and the Spring extension pack. Those are the two extension packs you should install, the Java extension pack and the Spring extension pack. And if you need help while running Spring tools, using Spring tools, whatever, I added a few URLs for you. So you can take a look at the user guide, file issues. You can ask questions on Stack Overflow with a certain tag. You can contact us on Twitter, of course. And with that, I would like to say Thank you. Thanks for watching. Hope it was gave you some nice insights, and hope this helps you to be more productive today, or at least tomorrow and within the next weeks, hacking Spring Boot applications on Visual Studio Code. And with that, thanks from my side. You can reach me on Twitter or via email for additional questions. Also, feel free to go to the Spring Tools for Twitter account for questions or for updates and news, or file an issue if you find something or have an idea for an additional feature that you would like to see. With that, thanks a lot for watching, and hope you enjoyed the session and have fun at the rest of the JDConf. Thanks.
Brilliantly done, Martin. And there are 1.5 million active users on Visual Studio Code, and they all get access to that tool suite, and it's for free. They can start using it now. It's got a lot of features that you actually pay for in other IDEs, and it gives you, like you showed there, introspection to your beans, the ability to look at your Spring code, to do Spring-based activation and introspection. Yeah, so it's great. I want to bring in Kevin now, because Kevin actually is complementing your talk, because Kevin's going to show, with all of that, those powers, how to do end-to-end testing. Revolutionary with test containers, though. So I want to say goodbye to Martin and introduce Kevin with his incredible talk. Kevin is going to be the last speaker, and then I'm going to do a round off at the end of it, though. So over to you, Kevin.
Yes, thanks, Rory. Bye, Martin. So from the talk from Martin, I also learned that I should have maybe installed the Spring extension, which I haven't, but we will still look at Spring code, and we will look at testing Spring code, integration testing it, and not only with the Visual Code, but actually using GitHub code spaces, so in a cloud environment, cloud IDE, so to say. And I'm so convinced that cloud IDEs are thing we can start using, that I'm now doing this session and this live demo while I'm currently on an island in front of Stockholm, in the Stockholm archipelago, Grinda Island. And yeah, still I have some internet here, and good enough internet to do the live demo. So let's get started. Okay, so we will look at a very simple example Spring Boot application that is purposefully built in a way that it will use a lot of external components. So we are, and maybe I just realized I haven't introduced myself, so I will do this now quickly. My name is Kevin Wittek. I'm a software engineer at Atomic Jar, and Atomic Jar is a company that is maintaining test containers, the test containers library, and we have as the biggest variant of it test containers Java, a library for integration testing, helping you integration test and instrumenting Docker containers from within Java. I'm one of the maintainers, and yes, therefore we will look into those things, how to do integration testing in this cloud IDE environment, which is the same as locally, actually, what we will learn. So this Spring Boot example application we have here, it consists of a controller, a ratings controller. The idea is that we have talks of a conference, and we can record ratings for these talks. So we have this ratings controller, and it talks to a couple of repositories. So there's a talk repository, and the talk repository will interact with a very classical database, a relational database, Postgres in our case. Then we have a further ratings repository. The ratings repository will then store the corresponding ratings for a talk, and they will be stored as a persistence technology in Redis, in memory store. All right, and to actually persist the ratings, we are using an eventing system. So the ratings controller will send the ratings to Kafka, and then we will have a listener that listens to these new ratings events coming in, and this rating listener will then persist the ratings in this ratings repository. So especially the round bubbles we have here in the end are all components we will have to integration test when we want to do real end-to-end integration test. And yeah, let's look at how we can do it and how we can get started. I'm having here a simple Spring Boot project open. I could do it with Gradle, I could do it with Maven. I'm doing it now with Maven because I think in Visual Studio Code currently the support for Maven is sometimes a bit better, although both are generally having quite good support. And we won't look at the actual source code of the different production classes, controllers, and so on, because that's not so interesting for us. But we want to look at the Maven POM, because what do you need to do in Maven when you want to get started with Spring Boot? You need to have we don't need this plugin. You need to have a dependency on test containers, and one way to declare dependency on test containers is just declaring this BOM. So we will make sure if we use multiple modules from test containers that we will have the correct versions. So we include this BOM, and then we say here which modules from test containers we want to have. So we want to have Kafka, Postgres, also Jupyter integration will also be nice. And that's all you need. And then you are ready. You don't have to install anything. You need to have a Docker daemon available, okay? Somewhere. So test containers needs to run with Docker, interact with Docker. Now I'm, as I said, in CodeSpace, in GitHub CodeSpace, and I defined my environment using a dev container. And how do I get Docker in this case? So you can run through these wizards that VS Code provides to you actually, and it asks you a couple of questions like what do you want to have, Java, JavaScript, and so on, what kind of Docker you want to have, and it generates those two files, the dev container JSON and the Docker file. And here in the dev container JSON, we see we have a feature enabled Docker in Docker latest. And this is one of the ways how you can use Docker, and by this enable the usage of test containers in Visual Studio Code using GitHub Codespaces. There are other ways as well, of course, and locally it would work also when you have Docker there installed, Docker Desktop, or anything else. All right, so let's get started with the first test and start to get a feel for things. So we are here. I have some empty packages, but nothing really yet. So what I will create now, and that's a pattern we generally like, is an abstract integration test class. And this, wait, I want to have it here, the support package. Integration test. All right, class, abstract class. Okay. And we generally find that for Spring Boot tests, it's nice to sometimes have this abstract class for describing all the environment properties you will need, or infrastructure properties you will need for your integration testing. And yeah, integration testing in Spring you can do with Spring Boot test, at least one kind of integration testing. I would call this is within process integration testing. And we want to have a web environment as well. And this web environment should start on a random port. It's also in general a very good recommendation. Always make sure if you're starting processes, starting servers in your integration test, make sure they run on random ports and you won't have any port conflicts. All right, and yeah, we saw it in the talk before. One test we generally have in the beginning, and it's a really cool test. I like it. It's useful to have such tests. This one that just says checks that the context loads. And yes, indeed, now we can just, and this we don't want to have in the abstract test here, sorry. So this I will do in my demo application test, which I will create here. Demo application test. Okay, this demo application test will extend the abstract integration test. Okay, put it here. All right. Import here Jupyter. All right, and now we can run the test directly from within VS Code. Quite convenient, and we expect it to succeed for now because we haven't done anything that should break it. At least I hope so. So yes, it succeeded. Yes, it's green. Cool. And now let's start by bootstrapping our database. And with Spring, one very easy way to do this is just dump a schema SQL file here in this folder, which I have to do from this folder. right? In the resources, in the test resources, we can just dump the schema.sql file. Okay, I already have this prepared, so I'll just paste this in here. Okay, so this file will create our table, relational database title with ID title, and then we will insert some talks into there. And yeah, if there's any conflict, do nothing, because this is like something we know Postgres supports, and it's fine Postgres syntax. So let's run the test again. And we would expect that everything should be fine, but it is not. Okay, we see there is an exception being thrown. Let's look into this exception. What happened? Okay, we get a syntax error here. And why is this? So in Spring Boot, if I don't configure anything specifically, it will directly use for this JDBC connection H2 as an in-memory database replacement. And in the default mode, H2 will not support specific SQL syntax of other databases, in our case Postgres. So that's why we get here an error. So what do we do now? We can now try to configure H2 to make it compatible, change our SQL to make it compatible with H2, and so on. But actually what we want to understand is if it works with Postgres, because we know in the end we want to run Postgres as our persistence layer. So let's go ahead and test against a real Postgres database. And yeah, I could now from the command line start Postgres or whatever, but that's not what I want to do. I want to make sure my test starts Postgres for me as part of the test process. And for this, I will use test containers, and I will use the test containers JDBC integration. I'm just copying, we'll just copy here property in. All right. So I'm setting my Spring data source URL. I could do this also in the application YAML, but I want to do it here in the annotation. And I set this to this special JDBC URL. This will then load a test containers JDBC driver. That's why we have the TC here. And this driver proxy will intercept the connection and will see, okay, someone wants to talk with Postgres. Okay, let's give him Postgres. And then it will start a Postgres Docker container and then proxy the connection to a database connection to this container. And then afterwards, when everything is done and we are done with the test, it will just remove the container. We will have no containers left afterwards. So let's run the test again. Same time, we can open here the terminal and check what is happening with Docker. Okay, now we see the Docker container popped up here. Do we actually also see the test output? So it was green now, but I didn't see the test output because I opened the terminal. Whatever, we see the test is green, everything succeeded. We see a Postgres container popped up, Postgres container is gone now. There was another container, this is a helper container from test containers that will make sure we clean up everything afterwards. And yeah, all good, everything cleaned up. Let's run the test again so we see the output. I'm not seeing the output. So you can see I'm not that usually using VS Code that much. That's why I'm not sure now why the output doesn't pop up or where in those windows. Here, debug console, cool. Yeah, so we see in the test run that these logs appear here from test containers. So we see test containers starts to detect Docker. Okay, what kind of Docker I have here? Yeah, this Docker variant built by Azure. And then it checks some preconditions that there is enough free disk space and so on. So we could fail early if we know we can't actually even interact with Docker or we can't containers. And then once you see this nice little whale pop up here, you know, okay, these are also logs from test containers. Now some things are happening with Docker containers. So a container is created for the Postgres image and then started, and then Spring Boot continues and the test succeeds. All right, good. So this was now the first small example where we already use test containers. And you can do, like, if you go to your project and you want to start using test containers, you're currently using H2, all you have to do is replace your data source URLs that you might have defined in testing with the H2 one. You just replace it with this Postgres one. Okay, but now let's go further and make some more interesting tests. So let's check what happens when we interact with our application. So we go again into the abstract integration test class here. And we now want to prepare basically the code we need to do some REST assured tests. We want to run some tests against the REST API. So let's format everything. Okay. Let's do the imports, organize imports. Cool. We want to have this. All right. Okay, so I copied a bunch of code in here because I wouldn't have time to type out everything. But we are now setting up REST assured, so we can run HTTP REST tests against our Spring Boot application. After it starts up, we inject the local server port here, and then we just set up REST assured. That's all that is happening here. And in the demo application test, we now want to call the Spring Boot actuator health endpoint to just check, okay, is our Spring Boot application healthy after we started it? Sorry, rest assured. Give. All right, let's run this test. And I will drink a bit because I have a bit dry throat. Okay, we see again, okay, Postgres is starting up. That's what we expected because that's what we defined in the abstract integration test. Okay, and now this is failing. And I love that Visual Code directly jumps here and throws the assertion arrow in your face and says, okay, here your test failed. Please look at this and have a look at it. That's pretty cool. So we see the actuator health endpoint didn't respond with 200. Oh, how unfortunate. Why didn't it respond with 200? Okay, if we look at the output from the actuator endpoint, we see that we have here a couple of indicators that all need to be up for the application to be considered up. But one of them is down. Redis is down. Okay. Yeah, sure. There is no equivalent of H2 for Redis that Spring could just throw in there. And we haven't yet started Redis. So we have to make sure we have Redis available for our tests. Let's also do this with test containers. Sorry. So I'm now defining a generic container here in my abstract. And sorry, I have suddenly a really dry throat. I can't help it. So you have to live with this. So I'm now defining a generic container, which means before we had this very convenient way to just inject this magic JDBC URL, and then test containers would start the container once we would have the connection to it. Now we need to use a very classic integration, which is I'm so sorry. So sorry. Now we have to use the classic test containers integration, which is using an object-oriented abstraction. So we have to define a container object, and the generic container object is the most flexible one. You can throw any kind of Docker image in there, and then it will just work, just as doing a Docker run in a way. So we want to have a Redis 6 Alpine. All right, and now we configure it a little bit. So we say with exposed ports 6379. Okay, so then test containers will automatically map this internal port of the container to a free port on the host, a dynamic one, random more or less, a randomly free one. And now we need to, of course, make Spring Boot aware of this. So we need some way to configure Spring that Redis will be, where will Redis be reachable? We don't really know it beforehand. We will only know how we can reach Redis after we started the container, because once the container is started, it will map dynamically to a free port, and then we need to inject this dynamically mapped free port into our system under test, into our Spring Boot configuration. And luckily, the Spring team added a feature that supports exactly this use case beautifully, and that's dynamic property source. I just copy paste the block in here so we don't lose too much time. Format and organize imports. All right. So what does this allow? It makes sure you don't have this chicken and egg problem with making sure that the time your test framework runs, the containers start, and Spring Boot context is initialized, that this aligns. So this helps you to basically perfectly align it. Because we now know these are properties, or this is a way for Spring to configure properties that will only be known once the test starts to run. Now we can nicely do it like this. So we start the container here, and then we add here the settings in Spring Boot, and the container object from test containers already provides us a method, get host. This will be the address under which the map port of the container will be reachable. This can be localhost, but can also be something else. In this case, I'm not even sure in our setup which the containers are reachable on localhost, but actually I don't have to care because the test containers abstraction provides this for me. All right. So, and then here, this is what I meant. We need to map the get the dynamically mapped port, inject this in another system on the test. And test containers provides methods for this as well. We can say get first map port, which is enough in this case, since we only have one port. or we could say specifically which map port we want to have. Okay, let's try the test again. All right, everything green, that's what we wanted to see. So now the application responds as healthy, exactly how we wanted. And I try to rush one more example now because we haven't seen Kafka yet, and maybe I can make it in time. So let me try to rush this. We now want to test the API and want to test it for our actual business logic that we can create ratings and query them, etc. So we want to create a test here, ratings controller test. All right, I just copied in a bunch of code here. A couple of rest assured tests. We are calling the REST endpoint, checking what happens if we query ratings, if we save ratings, etc. All right, what happens now if I run this? So if I run this, we see here a couple of warnings actually in the log already. Okay, something with Kafka. This will not succeed because we haven't yet set up Kafka. We need to spin up Kafka and integrate it into our test. So we can leave this running a bit, but I can guarantee you this will now ultimately fail. Let's go into our abstract integration test. Also define Kafka, and we have a static, we have a special class that makes running Kafka with test containers very easy. Kafka container, all right. Container Kafka equals new Kafka container. Okay. Now here we have a little bit different API in the constructor for historic reasons, which I don't have time to explain right now, but we need to define it like this. So we always have different flavors. Sometimes you can specify the image name directly. Sometimes you need to provide here the object, Docker image name object, so it gets not confused with tags and so on. I sadly can't go into too much detail here right now because I'm running out of time, but I will just use this image. Right. So we want to use this Kafka image, and we will use this tag here, 543. All right, that's it. We need to start Kafka here. Okay, and then we need to add a property here as well. And maybe I can really make it in time. I'm trying my best. On the minute exactly. So here we want to specify for this property, and on Kafka we have a method Kafka get bootstrap servers. All right, so and if we are lucky, or not only lucky, if I didn't make any typing mistakes, it will now simply work. And yeah, let's run it. We will also see Kafka will start now. So we see Kafka image gets pulled. Right. If we do here the watch .ps, we see the Redis container is already up. Kafka is now up. We will also see Postgres appear in a bit. Okay, here we have Postgres. So now everything is running. All those dependencies are running, and all has been defined from within our code, from within our test code, from within our Spring Boot test. And if I didn't make any mistakes now while coding, yes, this looks excellent. We received the ratings, the tests are green, everything worked, and in, I don't know, 20 minutes, we brute forced here the complete end-to-end test with all those integrations. Everything now defined as code, and the next colleague that will want to work on this can just clone the repository after I would have committed it and will be able to run the test directly without having to install anything, any of those components, no Postgres, no Kafka. The tests will provide it by themselves. And if they also use dev container, they even get the development environment, the correct one, they can directly run from GitHub code spaces. And I think this is a great future for software development, and basically reaching this point of just cloning a repository and running it. Yeah. So yes, I think that's my talk directly in time, I hope.
That had me on the edge of my seat for a lot of your talk, though. And yeah, it was riveting. And I've never seen, because when you live code, you're live coding with the actual systems in there, with databases, with integration. And it's a whole different experience. And you go, normally they go, no, I've got an in-memory database. You can do this later. But you actually did it with a connection with test containers. So I can't guarantee I can do that, but I'm going to go look at test containers on how to actually improve my demos from now on to do that. Thank you so much.
Yes, everyone can do that. Yeah.
It was a great end to a great day.
Thank you.
So I'm going to share my screen, and I've got some material that I'm going to show you. So if you want to learn a little bit more about Java development, let's go back there. PowerPoint don't misbehave. There we go. So I'm a co-author of the Learn Path. So you can go to JDConf-learn, and you can access the Get Started with Java on Azure. It's the Learn Path here. And there's a lot of material here, and you can go through it in your own time. You can get a badge for all of that material there, and that is the JDConf-learn. We already have some of the material on demand. Yeah, while we were busy talking, the previous day's talks already are on demand. So you can go onto JDConf-demand. You can see here are the talks that they did yesterday. Shai actually spoke twice. And there's a talk there. You can go and access that JDConf-on-demand. And finally, all the resources, we asked the speakers to give us the resources, and they provided the resources there. You can go to JDConf-resources, and you can see here on the last little bit here, the JDConf-resources. We have items in this collection here. So all of the links that we mentioned there, and also the security, Quarkus, Kafka streams, and Bayesian optimization, and yeah, even the test containers there. You can go in and test Kevin's great demo that we did there. So those links again, that there. And then I'm going to love you and leave you. You've been a great audience. And we've had so many incredible speakers here today. I do feel like I need to up my game a little bit, because I've learned too many technologies to just sit and do my business as usual demos. And you can actually reach me on Twitter. And thank you to our incredible Learn TV hosts and our producers sitting in the back round. And thank you, everyone. And I look forward to seeing you on the Twitter sphere. Cheers, everyone.